Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCIE data center 3.0. Those are the new uploads as well. So please go continue your learning, take the coupon, enroll my courses, and study well. All the best. Hi everyone, welcome to Cisco Meraki course. This is also one type of SD-WAN solution where we'll find there are lots of things that is automatically there with respect to SD-WAN solution, with respect to security solutions, with respect to wireless solutions. So this is something like all-in-one feature set in a Cisco domain, or to provide a solution to a mid to a high scale customers. So we'll see one by one all of the features and the uh, task operation related to Cisco Meraki. While using any type of SD-WAN solution, if we use that, we can reduce the capital expenditure, operational cost. We can improve the performance and the scalability as well. And obviously we have the enhanced security. So if I compare Meraki with other SD solution, so what type of other SD solutions we have? We have plenty of SD solution. One is Meraki from Cisco and other is Cisco Viptela SD-WAN solution. You can think Meraki as a mid-size of clients. They are using this. And if we are thinking about the enterprise scale, so enterprise, even the mid-size company also they are using the Cisco Viptela solution. Meraki is completely cloud solution, but Cisco Viptela SD-WAN solution, even we can host over a cloud, but we have option that we can have our infrastructure as well. Likewise, parallelly we have other vendor SD-WAN solution as well, like Versa SD solution, that is very much for ISPs. Means generally ISPs they are using this SD solution. Then we have a VMware Velo Cloud, and Velo Cloud solution is very much equivalent to Cisco Viptela. Means you can think this as a enterprise level cloud solution. But apart from that, if you compare, you will find that still we have so many variations of SD solution. Out of those, Meraki, Viptela are the most popular among the ISPs. This Versa solution is gaining the popularity, and obviously VMware they have their own clients. They are deploying or they are proposing this solution to their client. Now, irrespective of what SD solution we are using, if we use SD solution, then this is important term that zero touch provisioning means you can auto deploy the branches. You don't need um, you don't need workforce, or you don't need approvals and all those no big cycle to deploy your solution. Rather, from a center controller you can push the template to the branch and the branch will start functioning. The other good thing about all the solution there is that because they are using the template, so what you have to do, you have to build the template and then you can push to thousands of your branches. Only things will change that what is the IP addresses and what are the minor changes respective to that branch. Those things will change. But this is true for all the SD solutions. Zero touch provisioning, template feature. This is also a neat thing that you have your data center somewhere and you have your branches spread across the globe. Once you bring up this solution in Meraki, you have to do some clicks, but say in Cisco Viptela, automatically your VPN tunnel or IPsec tunnel will form. Again, if we compare this with the legacy or the traditional infrastructure or traditional WAN environment, we'll find that it's very difficult to manage or to build or to do the configuration for these VPNs. But in the Meraki solution, it is very much like it's auto VPN. You see, auto VPN. Automatically, it will form the VPNs. It's very easy to do the diagnostic from your central device, and it's very easy to enforce the security policy. The last point is also very important because nowadays everything is managed via a single controller, that is your management or your centralized managed dashboard. So everything is managed via dashboard. So you can manage your entire Meraki infrastructure with help of a single dashboard, and this is true for all the controllers. With all the controllers, with all the SD solutions, we have such centralized managed engine from where we can manage everything. Even we can connect this with the REST APIs, and with help of API calls, further we can provide solution to my branches, to my data center, everywhere. Okay, so these are the things like zero touch provisioning, the template, the security, that is the auto VPN, the diagnostic or the secure policy, the centralized management. These things are the characteristic of the SD solution, and that is the one reason why this SD solution from last 5 years, they are booming in the market. In Meraki solution, what type of features we have? We can provide the SD-WAN solution, and in the upcoming sessions we'll see that how it can be achieved. We have the automatic or self-healing VPN or auto VPNs, secure operations, because this Meraki product portfolios, they have so many devices: Meraki secure devices, Meraki switches, Meraki access points as MR, and some other devices. We'll check the portfolio for this solution. With help of MX, we can provide security. This is a switch and this is my access point where we can do the routing and other capabilities. It is highly available and failover is instant. Okay. So before moving further, let me go to the Meraki dashboard and let me show you some of the neat features, because we discussed that we have WAN feature, then self-healing VPNs, all these things. So let me quickly go to the dashboard and let me show you the features. If I click here in the dashboard, you can see in my case, I have data center 1 and data center 2. Let me scroll. I can click here, you can see DC, secondary, primary, and I have 2 branch. Means I have 2 DC, I have 2 branch. This is my centralized dashboard. So if I want to go inside my DC secondary, I can click there. Inside DC secondary, if I go to security appliance and the appliance status, I will check that what type of appliance this is. and this is MX. This is my security device with this MAC address. Here you can see in this particular dashboard that I have other options like the summary, uplink, location tools. If I click to uplink, it will show that how it is going from my device to the ISP. So the topology is very much the same that you have for your traditional WAN, that you have DC, say DC2, it is going to cloud, DC1, it is going to cloud, then I have branch 1 and branch 2. At the moment, this is connected only, means I have only one connection from here to here. Okay, and we'll see the branches as well in the upcoming sessions. But what is the main point here, that you can go to say one of the branch. I click to that branch. From a single point, I can go to any of my branches. Here you can see that one is going towards internet, one is going. We can check the topology as well. If I go to the network wide and if I click to the topology, so here I can figure out what is the topology. It is showing that okay, this is connected with the switch in the downlink, and that switch is connected with the access point. From here, obviously, it is connected to the ISP as well, or the cloud as well. But the important thing here that you can see that from a single dashboard or single management engine, we can go to any of the branches, and from there I can check all these things like, okay, in this branch I have one switch, one wireless router. If I want to check about my wireless access point, I can go to wireless and then access point, and I can figure out, okay, what is the uplink, what is the downlink. If I want to go inside this particular device dashboard, I can click there. I can go inside this dashboard. I can see, oh, these are the things, and these are the application, these are the utilization. Everything will get from a single pane or single uh, controller. Okay, so let me close here. This was the introductory session, and in the next slide will next recording will uh, go further and check some other options as well. Let us continue our discussion and see that what types of features we have in Meraki. As you can see that we can do the SD-WAN. We can integrate that SD-WAN with auto VPN, means these two comes together inside single SD-WAN solution. After that, we have the secure operations. Secure operations means we have all sort of firewalling options in Meraki. We can do the next generation firewalling, intrusion prevention. We can do the content filtering plus the malware protection. So not only the traditional port filtering, but we have the content filtering, that is the advanced firewalling options as well. Apart from that, this solution is highly scalable and they are 99.99% of available, and the failover is seamless. All these features we have in our Meraki solution. With respect to SD-WAN, what we can achieve. So say if I have my data center and all the data centers are something like this, that you have DC1, you have data center 2 as your DR, then across the geographical location you have branches. What is your final goal here? That you want to reach from here to here. In this solution you have any to any type of VPN connection. So suppose if anything happen with this VPN circuit, you will be automatically fail over to the other VPN circuit and your traffic will go. Okay, so that is one thing, that is the dynamic path selection. Means not only you have the dynamic path selection, but we can have something like policy based path option or path selection. We have active VPN circuits as well. So not only one circuit is up and running, but the other circuits will also have the same capability. They will do active load balancing to the other VPN circuits. That's also true. And that is and finally we have the policy based routing. Policy based routing is something like, suppose your voice traffic, for this you want MPLS, and for other low latency traffic you want, say, internet circuit. So we can create policy, we can prioritize the voice traffic over MPLS and the other traffic over internet, and final failover means finally everything will go over internet. So ISP 1, 2, 3 according to your SLAs, according to your bandwidth options, you can prioritize that. That is one of the neat thing. And other important thing that you can do it with few clicks. That's it. You don't need lengthy CLI configuration, so much planning. All these things will be there. Simply you have to go there and you have to click and things will be enabled. Likewise, we don't need lengthy VPN configuration. You have auto VPN option. With help of only 3 clicks, we can create VPN, and those VPNs are something termed as auto provisioning or auto VPNs in Meraki solution. Apart from that, we can change the parameters. So once you have your VPN tunnel, obviously your phase 1, phase 2 is up. Then if you want to change your pre-shared key or MD5 or hash encryption keys, all these things, it's very easy to change all those parameters. We have flexible tunneling plus topology and security policy. It's very easy to apply or remove the policies because everything we are managing from a central dashboard or single dashboard. So that's why it's very easy to change the parameters and it's easy to configure and provision the VPNs. Then the final feature we have is the security plus the auto failover. In security, it's really secure. You can see here that we have all type of security capabilities in Meraki solution. We can do firewalling, we can do IDS, we can do content filtering, all these things. So let me walk you through all these things one by one. We have this option that we can do the L7 traffic classification and control. We can go in depth of the packets, the application traffic, and we can check the content of those packets. Then we have the identity based policy options as well, where we can check the policies and we can identify that who is sending where. According to that, we can apply the rules. Because it is easily integrated with Cisco Firepower, so that's why there are lot many options that we have inside Firepower. Same things we have inside Meraki solution. You can see that we have options related to vulnerabilities and related to known exploits, something like virus, rootkits, and backdoors. All these things we can do with help of Meraki solution. It's very easy and simple to deploy. So that is the overall goal of this Meraki solution, that it's very easy to deploy. You don't need so much things to do while deploying Meraki SD-WAN, Meraki security, any type of failover. Everything will be seamless. It's very easy. It's all the time we have the availability, easy to deploy, easy to monitor, maintain. All these features we have, and we can have this reporting options as well. And if you want that if certain threshold values will be breached, then you will get the emails as well. Again, the same line that we have the content filtering plus the malware protection policies. We can integrate with AD servers. We have other options as well for the integration. And because it is integrated with the cloud, so your traffic first will go to the cloud. If you have any issues with the traffic, it will terminate the connection. Otherwise, it will go to the destination. Okay, so we have this cloud-based signature updates as well. Okay. Then finally we have the failover and the high availability options, and it depends that what type of policy-based routing we have. So if it will breach certain SLA, obviously it will go to ISP2, ISP3 like that. Warm spare failover is also there, and that's why the data center availability is very high in the Meraki solution. Right? So if I summarize all these things, that means we have SD-WAN solution, we have this auto VPN, auto provisioning solution, security. You have seen that for security we have all those options. Not only we are doing the firewalling, but we can do IPS IDS. We can check the malware, rootkits, signature, anomaly, all these things we have. And finally, we have this high availability and the failover features. In this section, I'm going to show you that what types of devices we have in this Meraki solution. And at this point of time, we know that, okay, we have various security devices, switches, various routing devices, not exactly routers, but routing devices. And you can see here, we have security cameras, some mobile devices, phones, wireless access points, some management engines, MX, the APs. So all these devices we have, and because now this Meraki is really big, and you can see they have this much customer at the moment, means so many Meraki switches or routers or security devices are in use. So let me walk you through one by one all these devices. Starting with the high-end Meraki devices, that is the security appliances or security devices. We have MX series devices starting with MX64 to virtual MX100, and you can see here the series and the generation. Uh, they are capable of doing template-based setting. They can integrate with wireless. They have two dedicated power over Ethernet. They can do auto VPN. We have Meraki SD-WAN solution capabilities as well in these devices. Okay, so these are very important things we have. Let me go to the next. Before going next, just to summarize all these things. So what we can do, we have SD-WAN feature, we have security feature, means it can be integrated with L7 security features, Cisco AMP, Cisco next generation IPS, content filtering, geo IP filtering, all these things. Plus we have VPN features. Okay, all these features with this MX. So one of the powerful tool in Meraki solution, we have this MX switches. Then the next generation or the next important thing is the managed wireless access point, and they are something MR. So after MX security, we have MR. They can automatic monitoring this Wi-Fi standard they have, enhanced transmit power receive. So you can see all these features that we have with the wireless devices. We have all these features here with this MR series wireless appliances or devices. Next we have switches. and we have long list of switch. Here you can see in the switch portfolio. They can create email alerts, stacking. They are powerful tools. They can run packet captures, highly redundant, in the top of rack fiber aggregation. So this is also there. Next, we have the Manager Enterprise Mobility Management Engine to do the asset management for rapid provisioning, remote live tools. Okay. So this is the mobility device management tool we have, and we have single interface for that. Okay. So if I integrate all the solution, now you can see that okay, we have MX for security, we have MR for wireless and the routing capabilities. Then we have MS for doing all the LAN switching or the switching capabilities. Then we have MDM that will do the asset management or provisioning or the live reporting, all those things. Apart from that, we have the security cameras as well. Obviously, they can monitor it from the cloud, video call. So many various features we have in this Meraki cloud solution, cameras. Then we have cloud managed cloud communication. This MC cloud managed communication. What we can do with that, centralized cloud management, IVR call groups, wideband audio, contact and phone integration, easy onboarding. Means these features are there with the Meraki phones. Okay, so this is the Meraki product portfolio. Obviously, if you want to know more about certain product, you can go to Meraki website. There you can check the data sheet related to MX64 or MX64W. Likewise, so in the high point of view or high level point of view, we have a single dashboard inside the cloud from where we can manage everything, all the devices, what irrespective of MX, MR, that is the wireless, MS, that is my switch, and then the cameras, then the phones, all these things we can monitor from a single interface or single pane of glass. So I'm good to close this particular section here, and in the next section I'll show you that how we can at least log to all these devices with help of Meraki Dashboard. Let me walk you through the Meraki Dashboard. This is the Meraki Dashboard, and here if I want to see that how many data center and branches I have, you can see here I have 2 data center and I have 2 branches. Now if I click to all network, so it will show me all network, whatever network I have. You can see we have data center primary, secondary, branch 1 and 2, and how many devices associated with these data centers. Means we have the list of that. If I click to devices, then it will show me the devices and the public IP addresses with those devices. Here you can see that in my data center I have MX64. So in total I have 6 MX devices, means those are the security appliances, and we'll see in the upcoming sessions that what are the features we have with the MX. But at the moment where I am inside the dashboard, and if I go inside the MX, so let me show you the features of MX. But apart from that, we have MR, we have MS, that is the switch and the router or the access point. Let me first go to the MX appliance, and if I go here and if I click, so I am inside RTP02 primary data center, and this is the dashboard for your MX appliance. Here you can see that the name and the MAC address is showing that okay, this is the currently master, what is the address, and then we have the fields like uplink, location, tools. So if I click to uplink, it will show me okay, where it is connected, what is the traffic for the uplink, what is the latency and the loss for the WAN. Okay, all these things we have. If I click to location, it will show me what is the geographical location for this particular device. And then in the tool option, we have ping, LED, throughput, trace route, mean time to respond, MTR, DNS lookup, ARP cache. All these things we have inside the dashboard of this MX64. Okay. So if I want to check that, okay, with this appliance, what features I have. So you can see here, we can create, means in the configuration tab, we can create addressing and VLANs, DHCP, firewalling, VPNs, Active Directory, traffic shaping, threat protection, content filtering, wireless concentrated. So you can see we have a list of features inside this MX. And suppose if we want to monitor, then we can monitor the appliance status, spare status, security center, VPN status, and route table. So let me click here to the VPN status. And once we are inside the VPN status, it will show you what is the status for the VPN and all those stuffs. Okay, so it has 3 side-to-side peers, and these side-to-side peers you can see here: DC primary, branch 1, branch 2, and I am here in the DC secondary. Because Meraki solution has auto VPN, so this particular secondary data center has 3 VPN tunnel, and obviously those are the automatic tunnels. What are the uses? You can see here the uses: latency is 0, connectivity is 100%. Okay, so likewise we can monitor all the stuffs related to MX appliance. Apart from that, what configuration option we have already checked, and in the upcoming recordings we'll go through it, no problem on that. And inside what we have web application performance. I can go inside web application performance, and here it will show you the Meraki control traffic, all the other traffic. In the network wide, obviously this is the network wide configuration, so we are responsible very much to this security appliances and then monitor and the configuration tab. If I go to the organization, suppose if I want to see that what is my inventory list, and if I want to do some changes, means suppose if you want to do some deployment to new branch, and if you want to copy the existing configuration, so all these stuffs you can do from here. I'll show you in the I will show you in the upcoming recordings, so please do not worry about that. But yeah, still you can see the devices, because this is obviously the inventory. We can select some devices, and then we can use, unuse, unclaim, claim, all options we have. We'll check that. Okay, so this is related to the security appliance, that is our MX. Let me click to the firewall as well, and inside firewall we can see layer 7 rules, layer 3 and layer 7 rules, bonjour forwarding. Okay, we'll check all these things in the upcoming recording. Inside threat protection, These are disabled. So if I enable, first we'll go through the theories of these threat protection and the intrusion prevention and detection, and then we'll enable that, and then we'll check that, okay, what we can do inside that. Traffic shaping. Okay, so in the SD-WAN deployment section, we'll create some rules and we'll check all those rules in the upcoming sessions. So likewise, we have all these options. Now, because this data center has only MX devices, say in Elkton, I have some other devices as well. So let me go inside branch Elkton. Here I have switch, here I have wireless, that is I have MS, I have MR as well. Now inside switch you can see what options I have. Okay, and inside wireless you can see what options I have. So let me close here, and in the upcoming recording we'll check the dashboard features of switch and wireless devices as well. Now we have seen the security appliance dashboard. Let me show you the other devices as well, such as MR, that is the wireless router, and the MS, that is the Meraki switch. Here I am in the DC, a secondary. What I can go do here, that I can go to branch, one of the branch. So I just click there, and that branch is Elkton. On that particular branch, if I click to network wide, obviously I can see that how many devices I have, but what I want here, I just wanted to see that how many devices we have in this branch. And once you go to that dashboard, what you will get there, you'll get that, okay, one switch is there, wireless device is there, security appliance is there. What will be the network topology for this branch? For that, what we can do, we can go to network wide and then topology, and then it will show you what is the topology it has. Here you can see that we have one MR, that is my access point, that is connected with switch. Again, that is connected with my MX, that is the security appliance, and from here it is going to the ISP, and from there it is going to the data center. So that is the overall topology we have. Now what I can do here, I can go to the switch because we are concerned about the switch dashboard. And if I click to the switches, obviously the switch dashboard will come. And this is the switch dashboard where we have the switch name like this, the MAC address, and we have other options related to this switch. Here you can see that 3 ports are used out of 10 ports. One is connected here, one is connected here. So what I can do here, I can go to switch and switch port, so we'll get the connection details as well. Let me click to ports. Here you can see we have the port and the CDP neighbor details. Port number 5 is connected with the MR, that is the uplink. One is, oh, MR is not uplink. Port number 1 is actually my uplink. You can see the up arrow here. This is my uplink. This particular interface here is connected with the MR, that is my access point. Okay. And suppose if you want to go to this dashboard or this dashboard, you can click and you can go there. No problem on that. Apart from that, you can see we have power option, how many PoEs are used, event log, what is the location, then the tools. Tools, you know what type of things we'll get in the tools. Tools related to ping, throughput, MTR, all these things. So here I am in the summary, and if I scroll a little bit down, you can see here that I'm learning MAC address of this PC. then MR, then PC, then again MR. And which ports they are connected is showing here. So I'm learning these MAC addresses over these ports, port 1, 5, and 6. Okay. Apart from that, what other things I can check? I can click to the switch ports. Now this time it will show you the port option, and here we have, you can see here in detail all these things. So once I am here, I have option to edit, aggregate, split, monitor, unmonitor. I can check something, means suppose if I want to monitor this port, I can click here and then I can click to monitor, and then it will ask, okay, you want to expand this? Yes, you can do it, no problem. Apart from that, split and aggregate options are also there. So if I uh, choose 2 ports, then I have this aggregate option. You do not have permission to modify these ports, so we don't have permission at the moment, but still you can understand that we can do the port aggregation, the monitoring, unmonitoring, all options we have here in the switch ports. Then I can go to DHCP server and ARP, where I will get the DHCP detail. Then these are related to monitoring. Then if I want to configure, I can configure routing, ACLs, access policies, port schedule, switch setting, and the stages option we have. That is a good option there. If I click to the switch setting, then inside switch setting we have the VLAN configuration, STP configuration, QoS configuration. So all sort of options we have. The good thing here is that we can do configuration with help of this dashboard. Other than this, we know about Cisco devices. So far we have done all the configuration related to Cisco CLI. Generally what we are doing in Cisco, that we are going to conft, and then we are going to certain interface, and then we are doing the configurations. But here everything we can done via CLI. Important thing that you need to know all these concepts. So you need to know what is VLAN, you need to know what is STP, what is limitations of STP, you need to know that how you can apply or implement QoS, DSCP, COS, you need to know about MTUs. So all these basic network concepts will be the same, only the way you are configuring it is different. Let me close here, and in the next section we will discuss about the wireless Meraki. Let us finally check the wireless dashboard. For that I can click to the wireless. Once I click to the wireless, then I have to go to wireless access point just to check that what wireless I am running. Inside this wireless, I can go inside this wireless access point. Here you can see that this is related to branch number, what is the MAC address with this wireless, what is the serial number, complete address, SSID. I can click show SSID. This is the SSID name, it is on. What is the status, what IP address it is getting, what is the public IP address. If I want to see the topology, I can click to the topology. Now again we are reaching to the same point. Let me go back. Likewise, we can see all the stuffs in this dashboard. Even here you can see the event history, what is the channel. Again we have the live tools related to the channel utilization, ping, ARP, traceroute, throughput, blink LED. And again we have information about the access point usage, channel utilization. So all these stuffs we have in the dashboard, which is very important. Then here you can see view new version as well. If I click to the new version, now it is showing the new version, and in the new version the dashboard is same that we have checked. I can go to the event log, location, tools, LAN, RF. And if I go to the LAN section, it is untagged. If I go to RF, radio frequency, it's showing the channels and all the stuffs related to access point. Let me go to the summary. Let us go back and see that what options we have here for the wireless. So for monitoring, we have the map, air marshal, location, class logins, PCI report, RF spectrum, configuration, whatever configuration we can do with the access point, all those options we have, like SSID, access control, and some of the features you can see, firewall and traffic shaping. This is we have with the security appliance as well, and here in the access point as well. Then the splash page, SSID availability, and then the radio settings. So let me click one by one to all these options. So if I go to the SSID option, here you can see that if I want to rename SSID, then we have options here. Options like SSID 234. I can edit the setting. Once I click there at edit setting, then this page, this is very much similar page that we are getting with the access points. Means if you are running individual access point and if you retrieve the information with help of GUI, you'll get the same type of information that we have at the moment. Then yeah, that is the access control. Then let me go to the firewall and the traffic shaping. And these things I'm going to cover in the upcoming sessions. And this dashboard is very much similar that what we have with the security appliance, firewall, and the traffic shaping. We'll check that. Here you can see that in the MR we have firewall and traffic shaping in a single tab, but here in the security appliance, that is the MX, we have separate firewall and separate traffic shaping options. And in the upcoming sessions, we'll see that how we can block the URLs, how we can do the traffic shaping, how we can enable or disable stuffs related to firewall rules. We'll see that. Then the splash page. Okay, and SSID availability. But you can see here how easy it is to track all those information, how easy it is to change the configuration. You have single dashboard, and from that dashboard you can manage entire infrastructure. That is the one of the feature set or one of the powerful thing in Meraki we have. And then finally the radio setting. We can set the radio frequencies like that. Okay, so what we have done so far, we have checked the security appliance monitors and configuration options. We have checked the switch, monitor, and the configuration options. You can see in the security appliance, we have so many security features. Okay, we can create auto VPN, Active Directory, traffic shaping, threat protection, content filtering, all these things we have. In switch, although we have less security option like we can create ACLs and access policies in the switch, and in the wireless again we have options, access control, firewall, and traffic rules. Okay, so in together if you mix all these things, you'll find that okay, the ease of configuration is there, plus it's highly available. Okay, from here it is not showing that how it is available, but it's highly secure. It's very easy to configure and maintain and monitor. So all these options we have in Meraki solution. This was the introduction of the dashboard tour. Let me close, and the next section will deep dive into the security appliance settings. In the MX setup section, let us first create the VLAN, and we'll check that what are the options we have while creating the VLAN. What is the task we have? We need to go to the configuration and the VLANs. For corp, we have this subnet 1020.10.0. For voice, we have 1020.11.0 subnet. And for testing purpose, I will use one VLAN called test, something like 33. And for that, I will use IP address 1020, say 12.0. Okay, so let us do this task. While creating the VLANs, what we need to do, I'll go to my MX appliance. Say I'm going to create VLAN in my security appliance, configure addressing. First, I need to go here. Let me show you that how we can do that. Let me go to that place. I'm here in the security appliance. I can go to configure addressing and VLANs. Once I click there, then I will reach to that VLAN section. In this VLAN section, you can see here that we have network wide mode. These are the deployment mode. In the deployment modes, we have either pass through or NAT. So let me go back in the theory. Obviously, it will ask for the name and then the deployment mode. In deployment mode, we have pass through or the VPN concentrator mode, NAT mode. What these modes are doing, while using the VPN concentrator mode, that will something pass through, and it's very much similar that what we have in the layer 2 bridge, means simply it will pass through. It's a bridge mode. We can think this as a one arm VPN concentrator, and it will pass through the segment. Now, what is the next mode we have? Next mode is the NAT translation mode, where this is working as a layer 7 firewall. Okay, so if we use this, that means we are using the NAT capabilities in terms of layer 7 firewall. Okay, so I'm going to use actually the NAT mode. Let me go back to my page, and I'm using in the NAT mode. And let me go back. So parallelly, I'm showing you the theories as well. Once we deploy in the NAT mode, then we have obviously the option, either we can track in terms of layer 2 or we can track in terms of layer 3. So both the tracking options we have. You can see here, track the MAC addresses. Use this setting if the client device are on the same subnet. I use this setting if layer 3 router or switch between local clients and the security appliance. Okay, so here I'm going to use in the layer 2 mode tracking. Okay, so once you are set up to this point, then we can enable the VLANs. And once we enable the VLAN, then again we have the options. So what options we have? So here in the VLAN section, you can see that either I can add a static route or I can add a local VLAN. Suppose I want to add a local VLAN. My VLAN name is say test. Suppose 12.0 MX IP. I need to check what is my MX IP here. So I can use 1020 say 12.1 as a gateway as well. So let me do that. And this is my test VLAN. Say 12.0 is my subnet. My VLAN is something 33. I'll check about the group policy and in VPN. Update. Now here you can see that I have my subnet local VLAN. Name is test. MXIP is this. VLAN ID is this. And these subnets like the data and the VoIP, they are in the VPN. I'm not using in VPN, so there's no yes, there's no no. Okay, let me close this. Now I have successfully added one VLAN. Let me go back and show you what options we have. So what I have done, the name, subnet, MXIP, the IP address of the MX appliance in a particular VLAN. It's okay. VLAN ID group policy. Here I haven't used any group policy, but if I have global group policy, I can use it. In VPN means we are advertising that VLAN inside the VPN. Okay. So my data and my voice VPNs are in VPN. Here it is not. To delete, I can use the X bar and I can delete that. No problem on that. So let me go back. If I want to delete it, I can click here. It's deleted. Now the second option I have here is to add a static route. So if I click here to add a static route, enable yes. It is asking for name, subnet, next hop. Inactive, you can see that we have three options, like always, while, next hop, respond to ping, while host respond to ping in VPN, yes or no. So let me go back, and while we are using this option, you can see here all the options, something like enable, name, subnet, next hop, all these things will be there. If I go to next, in active mode, we have three options. By default is always, route is always used, while next hop respond to ping means route is used only if the MX can successfully ping to the next hop, while host respond to ping, host is used only if the MX can ping to a specific host. So now we can understand this. Means the route is always on if MX is able to ping to the next hop, or MX is able to ping to the specific host. Okay, that's okay, no problem. Then host to ping in VPN. If you are using this inside VPN, if you want to delete it, you can delete it. Okay, so let me go back and check this. Name I can give test. Subnet is 2012.0. Say 12.1. Active is okay. In VPN, yes. Update. Now I have added this static route as well with the next hop always yes. If I want to delete it, I can delete like this. Okay, so this is a way we can create VLAN, either local VLAN or we can add a static route. Let me close here, and in the next section we'll see the other options related to this VPN. Let us discuss the other features we have. Now we know that in Cisco how we are configuring the ports. Once we are inside any of the ports, say F0/1 on that particular interface, then we can give the configuration something like switch port, mode, access, and then the access VLAN say 4030 whatever. Apart from that, we have option switch port mode as a trunk, and over trunk we can allow various VLANs, plus we can use the native VLAN option. So all these things we can configure here in Meraki as well with help of graphic interface. So for that I need to select any port and then I need to click. So once I select and click, then it is asking, you want to enable or disable this port. Say Disable means simply no shut. Disable means shutdown. Enable means no shut. So it is in no shut mode. Type, I can use access or trunk. Say at the moment it is a trunk. My native VLAN, something like switchboard trunk allowed VLAN or native VLAN. Here I'm using 10, but I have option. Drop untagged traffic, I can use 10 and 11 as my data and VoIP VLANs. Apart from that, over that trunk, what VLANs I am allowing. So for that also I have options. You can see here all VLANs, data VLAN, VoIP VLAN, what you are allowing. I'm using all VLAN, then update ports. So it will update like that. So if I go to this port and if I edit, this time I want to make this as an access port, then it is asking as an access policy. You can see we can use .1x. Again, this configuration is that port based authentication. Either I can use MAC authentication bypass or hybrid. If I use 81x, then it is asking me you can add to the radius server. From here I can click and then I can give the host port and the password. Okay, the primary and secondary radius servers. So you can see that how easy this is to use all these options. If I use, let me close here. If I use the MAC authentication bypass, if I use open, everything will be gone. If I use hybrid, again it will ask for the radius authentications. Okay, so likewise you can use the port configuration, and obviously you can see that you need not worry about the CLI configuration templates or CLI things. You can easily do that. Same thing you will find here in the PPT. We can enable, we can give the type, native VLAN, allowed VLAN, VLAN access mode. In the access mode we have the options. Let me go next. Next we have the dynamic DNS. So what type of DNS we are using? We can assign the DNS. DNS is simply that we know that it is used to resolve the IP into the name and name into the IP. Because we are doing things, means my traffic is translating towards my public cloud, so we need this DNS records. That option also we have. Even we can give our custom DNS name, say my MX90, and my security appliance will convert that custom DNS name into unique name. So let me show you that how it will be done. Let me go to the configuration. Dynamic DNS, you can see here automatic generation is enabled, so whatever name I will give, it will generate a unique FQDN name for that, and it will resolve the DNS queries. Finally, we have warm spare. What does it mean? That we can have the HA if we want to add multiple MX devices. This is very much similar to the HA pairs. So we can add more MX devices for high availability, and for that what we need serial numbers, and we have option either we can use virtual IP or the other IP. Let me show you that what does it mean while we are configuring it. So here if you want to add warm spare, you have to go to appliance status page. Let me click here. I can go there, and once I reach to my branch dashboard, here we have this option to configure warm spare. Let me click to this, and then if I want to enable it, it will ask for a valid serial number. At the moment no serial number is there. Once I'll give it, then it will add that. For uplink IP, I can use either MX uplink IP or I can use the virtual IP. Then it will ask the virtual IP, because say once you are creating cluster, so I'm using two MX, MX1, MX2, then obviously I need one cluster IP here, so I can use this cluster or virtual IP for all my appliances, and then it will work. Okay, so at the moment I don't have spare devices, but this is the option that we can add the HA in my network. Okay, so I'm done with this setup VLAN configuration. Let me close here. Next section will check other security options related to security appliances. Let us check that how we can do the traffic shaping in case of our MX appliance or in case of our security appliances. And one by one, I'll walk you through all the steps. Here are the example or the set that I'm going to perform in this section, that I want to set 5 Mbps bandwidth per client. Then how I can apply or how I can provide throughput or speed to the applications, how I can provide the throughput or the speed to the traffic classes, and how we can block or you know allow some of the websites or some of the sites or some of the prohibited sites like that. So let me get started. Obviously we need to go to the traffic shaping setting. How I can go there? I have to go to configure and then this option, that is the traffic shaping. Once I'm inside that traffic shaping, then you can see that we have various options related to everything. Means related to uplink, related to various applications, user traffic, all these things we have. So one by one, let me check all those things. Let me go to my PPT, and what we can do from the start or in the beginning, that we can provide bandwidth limitation to the uplink. These uplinks, they are carrying important traffic such as VPN traffic and the management traffic. Apart from that, we'll check that how we can set the parameters related to load balancing and how actually this load balancing happening, that say if you have two link, WAN 1, WAN 2, one is 1 Mbps, other one is 9 Mbps. If say 10 packets will come, then one packet will go in this direction and 9 packet will go in this direction. Means this is the load balancing that we have in our traffic shaping or traffic shaping dashboard. So we'll see that. Let me show you that as well. For that I need to go to my traffic shaping dashboard or the GUI. From there you can see that WAN uplink, and suppose if we want to set different speed for download and upload, then we need to click here on the details, and here we can change the parameters. So WAN 1, WAN 2, then cellular. I have my uplink where I can set what is my destination. So here I can add the subnet and the description. If I want, I can delete it. I'll come back to this live update interval, but before that, let us check that what is the load balancing method. So here you can see the load balancing. It will do the load balancing. Let me go to the next. We have the uplink preferences as well. We have this preference with related to internet or VPN traffic over WAN. So let me show you that. If I go to the flow preference, that is my traffic preference, then I can check my internet traffic, and here you can see that for internet traffic, my gateway is WAN 1, and this is for TCP traffic. If I want to add, obviously I can click here to add preference. I can choose UDP. Likewise, I can choose any. and again any, and here I can choose WAN 2. That's it. Then for VPN traffic, again I can give the preference. I can add the filter, say I want email as my say Windows or Hotmail. Then there are other filters as well. What is the policy? Policy is say load balancing and best effort. Save it. So once I save it, you'll come to know that load balancing on uplinks that will be suitable for best effort and this application inside the VPN traffic. Apart from that, I have the custom classes. Here also I can add my class with respect to latency, jitter and loss. And this is very much the SLA that we can define. If I want, I can delete all these things with a simple click. Okay. So let me clean this. Yep. Apart from that, we have list updated interval. What is that? This setting is somewhere here, and if you go to this information, this setting determines how often the MX, that is the security appliance, should check for updates to security list. Is it the hourly basis, or is it a daily or the weekly basic? Okay, so by default it is the hourly basic. That setting we can do. We can set the global bandwidth limits, and I'll show you this in the example. While enabling this, once we enable global bandwidth limit, then we can enable the speed burst as well. What is that? That suppose if your up and download speed is 5 Mbps, then you can burst up to 10 seconds if you enable this speed burst. How we can do that? So before doing this, let me go to my questions. I'm going to complete the first scenario where I want to provide 5 Mbps speed per client. And how I can do that? I have to go to global preference. Let me scroll down. And then I have to go here to the details. I can give 5 Mbps speed. So I need to use 5120, and then I can enable the speed burst. What does it mean? It will tell you that allow user to temporarily exceed the bandwidth limit up to 10 seconds. Okay. And if I click here simple, you can see that now I have per client limit of 5 Mbps. Okay. So these are the cool stuffs here, that we have all the options related to traffic shaping. And in the next section, I'm going to create traffic shaping rules. So let me close for now. Let us continue our discussion with traffic shaping. And in this section, I'm going to implement these rules that related to the application, related to traffic class, and related to some prohibited websites. What we can do here, that we can go obviously inside the traffic shaping rule, and we can change all those rules. So let me go to that section where we have the traffic shaping rule. In my device security appliance, then I can go to configure and then traffic shaping. Once I go inside traffic shaping, then I need to drag it down. Here we have this traffic shaping rule. For that I need to create new rule, and you can see here rule number 1, definition. This rule will enforce traffic matching any of these expressions. So if I click here in the add button, then it will ask me that what type of service I have, and inside that service what I want to do. For example, say blogging, database, email, and we have so many services here. So according to our agenda, what I need to take, the first one is to give a rule or have a rule for Netflix and Pandora. Choose a 1 Mbps down and 500 kbps up upload speed on this rule with low priority. Okay, so we need to search that where is my application Netflix and Pandora, and if I scroll a little bit down, where I will get that peer-to-peer. I don't have. I want Netflix and Pandora. Let me go up. So that's the thing, that you need a list where you have to know that where all these applications, in which segment, sub-segment these applications are. If you scroll down, if you come to videos and music, then you'll find Netflix, and in the same, I think, yeah, here you'll find the Pandora. So I found that what are my application. Now what I want to choose a limit, and per client limit. So let me see that what is my choose a limit 1 Mbps and 5 kbps. This rule with low priority, and I want this rule with low priority and 1 Mbps download. So this should be 1024 and 512. Okay, bandwidth limit, I can ignore network per client as well. Okay, so this is my one rule. Let me go back. Then it is asking that, okay, create another traffic shaping rule for all VoIP and video conferencing. Ignore network bandwidth restriction for this rule and ensure the application are treated as high priority. So these two conditions we have, that ignore network bandwidth restriction and it should be treated as high, because obviously this is VoIP and video, so we need that condition. So for that, what I can do, I can add new shaping rules. This time I want to rule for video and voice. For that, again, I need to scroll it a bit down. Here you can see VoIP. Here we have video. So I can all VoIP and conferencing, I can click that. This is all video and music. So video and VoIP, this is the one I am looking for. So okay, I'm good with this. So I have this video and VoIP applications. Then what I want, ignore network per client, that's okay. This should be treated as high. And DHCP tagging, I don't have any option for that. Means, what about the DHCP tagging? If I want, I can use the DHCP tagging as well. So that is my second rule here for VoIP and conferencing. Now what is my third rule? Turn on content filtering and use this. So actually these are the traffic shaping rules And if we go to our slides, traffic shaping rules, how we can use it, how we can create the policies. Now here, while we are creating the policy, we need to define rule, and we can define rule in two ways. Either we can select the application that we have used, or other way that we can create in this manner. Let me show you that in this, like, we can assign IP, port, all these things, and we can create that rules. So let me go back. Say I'm creating third type of rule here, and in this rule I want to add custom expressions, and I can give, say, google.com. You can see that this we can use. Okay, and once you use all these expressions, then you can apply rule here, means we can set bandwidth and all these things. Okay, if you want to delete, obviously you can click here and the rule will be deleted. Rule action, how we can use, we can apply the bandwidth limit. We have checked that already. You can apply that. We can give the priority as high, normal, low. We have seen that as well. Okay, and then what is the ratio for high, low, and normal, we can check here. Quality of service prioritization can be applied to layer 3 traffic, and we can apply the DHCP tag values as well. So that thing also we have checked. If we want to prioritize, we have this DHCP value as well for QoS settings. Okay, yeah, so we are very much done with all these traffic shaping rule. Actually, this and these two rules are related to that. Now this is something related to content filtering, that I can go here and then I can go to content filtering. Once I am inside the content filtering, then I have options to choose my URL, and then I can take the appropriate action. Okay, so let me close here, and in the next section we will check all these other settings. Let us discuss about firewall rules, and in this section what we'll find that what type of firewall rules that we can create over our Meraki security appliance or Meraki appliance. We can create layer 3, layer 7 outbound firewall rules, publicly available appliance services, port forwarding, one-to-one NAT, one-to-many NAT. So how we can reach to our firewall? For that, what we have to do, you have to go to your appliance. So let me go to there, and in the configure section I need to click to the firewall. Once I click to the firewall section, here you can see that we have layer 3 outbound rules. Then I have layer 7 firewall rules. Then I have forwarding rules, bonjour rules. So all these things I have. In the forwarding rules, you can see that I have this option called port forwarding, one-to-one NAT, one-to-many NAT. All these things we'll check one by one. So suppose if I am here in the layer 3 rules, in this rule, what sort of rules I have, or in this layer, what sort of rules I can provide. I can add a outbound rule, and let me go back to the slide. The outbound rule, it's very much similar to Cisco access control list, where you can create rules with respect to source and destination IP address. So source and destination IP. Then you can add source and destination port number.
But apart from that, we have other options as well. So let me show you one example that what fields we can give here. Obviously, allow or deny, what protocol, source, destination, port, comments, and not only in this format, but we can give the DNS name as well. So that is one enhancement to make this rule. Let me go back. And what is the limitation here with this? Limitation is this, that these rules do not apply to VPN traffic. Okay, so you can think that you have advanced ACL where you can add DNS names. You can apply everywhere except except for VPN traffic. So that is the whole goal of this rule. Okay, so ACL, whatever extended ACL is doing in Cisco world, including the DNS name, and here you can see that FQDN support it has. What it will do, the MX must see the client's DNS request and the server's response in order to learn the proper IP mapping. That is the IP to name mapping. That is the overall goal of DNS, that it will map the IP to the name, and you can assign rule like that. Point number 2, you can see that in some cases a client device may already have IP information about the web resources. This could be due to the client having cached DNS information. So all these things are there, but the point here that you can include the DNS name as well. That is the point. Okay? So let me go to my dashboard firewall rule section, and there, see, I have 2 hits. There, what I can do, I can add a rule. So I'm adding a rule. So allow TCP. The source and destination field should support multiple entries per rule. Enter comma separated IP or CIDR values. So I can give, say for example, any, 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 and this is my test. Let me scroll down so we can see this. Okay, and that's it. In this way we can build our rule. Okay, so you can see here that the rule building in Meraki is really very simple. Simply you can build the rule. Let me cover this cellular and the security appliance portions as well. Okay, but yeah, as a reference you can take this example. If you want to include multiple ports, you can use comma. What is cellular failover? Say if your security appliance has backup link as 4G or any LTE, then at that time these firewall rules are appended to the existing outbound rules when the appliance has failed over to using a cellular modem. So whenever you have cellular modem uplink, at that time this rule will be applicable. And here you can add a rule, but you know that what is the limitation. You should have 4G or LTE connection, then the failover rules will happen. Okay. Then in this section finally we have the appliance service. It's very much that firewall as an appliance, what firewall thinking with respect to ICMP ping, web, local status and configuration, and SNMP. So for the inbound ICMP, request, we can apply this rule. Okay, so any traffic that is coming from WAN and it wants to ping to my device as a host, means the destination is my ASA firewall for ICMP. For web or local status configuration, means if someone from the WAN wants to open wire.meraki.com, or even in case of SNMP polling. So at that time, how my device will react, that rule I can build in this section. Okay, and here you can use, only you have to put the remote IPs what you want to allow for ICMP or for the web local status and configuration, and it will start responding, means your firewall will start responding. Okay, so these are the stuffs related to firewall layer 3 filtering. In the coming recordings I will cover up layer 7 and the other portions. Let us discuss about layer 7 firewall rules. And this is the unique capability of Cisco Meraki devices, where we can create layer 7 rules with respect to various options we have, like web-based services, website, types of websites. And what is the neat thing about this, that instead creating rules with respect to IP addresses, we can create rules with respect to websites, and all those rules will be applicable for the all the IP addresses. Means you don't need a selective IP address. Instead of the selective services, those rules will be by default applied. That is the powerful option with the layer 7 firewall rules, and where we can apply this rule and what type of things we have in these rules. So it is that uh, we can select various categories. I will show you in the lab section. But yeah, we can filter layer 7 irrespective of IP address. That is the one goal. Let me go to the next slide. So here we can create rules, and by default the policy is deny, means I want to deny all these things. Suppose for example blogging, and then some blogging site, file sharing. If I click on the application file sharing, I will get list of file sharing application, and then I can select to deny them. Also, it is possible to block traffic based on HTTP host name, destination port, remote IP range, destination IP port combinations. That I'll show you in the lab section. Apart from that, what we can do in this layer 7 filtering rule, that we can filter based on geo IP addresses. In this case, we can filter based on country name, and then we can apply uh, there in the layer 7 firewall rule. So let me show you all these things. Let me go to my lab section, and here uh, down to this layer 3 we have this layer 7 rule. Click. It seems it's very simple one-liner, but it's not. Once I am inside application, if I click, you can see I have this combination of the application or the services. You can think like this, and in beneath we have host name, port, remote IP range plus port plus the countries. So if I click on the countries, then I will move to the geo IP blocking. Say if I clicked here, it is asking, okay, application from country means to and from, traffic not to and from. If I click here, then I will get the options. Say if I check Cuba, and then again I click here, and say if I took Iceland, okay, so this is okay. Then I can click here, and this time I want to create rule related to application. So suppose peer-to-peer, then all peer-to-peer application. So what peer-to-peer application we have? Say BitTorrent, and that is our goal. If you see the recording number 1, I want to deny all the traffic to and from BitTorrent. Okay, and if I have HTTP hostname, I can give it. Apart from that, I have the port options and other options. Let me web click here to web file sharing, and then say hot file, like that. So like that I can populate the rules, and these rules are applicable per application. It's not that it's applicable per IP, and that is the uh, flexibility, and that is the scalability of rules we have, that we can have list of rules according to our management policies, and then we can easily apply. So if you want to delete those rules, click, 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 and you will, you can delete these rules. So I'm good with this particular layer 7 section. Let me stop here, and in the next section I will discuss about this forwarding rules. This is the last section for the firewall rules. In this section I'm going to discuss about forwarding rules. Actually we have 3 different types of forwarding. We'll see all the forwarding rules, what are the types and all these things. So in this, if I go to my lab section, here you'll find that we have forwarding rules with respect to port forwarding, one-to-one NAT, one-to-many NAT, and bonjour forwarding. So you can think that we have actually 2 forwarding rules. Inside forwarding rules, 3 different variants, and one is the intercommunication between the VLANs. Okay, so let us go back to the slide, and one by one we'll discuss all these things. First, if we apply the forwarding rules, then what we will get, that in this forwarding port forwarding rule, we can forward a port obviously, but what is the limitation here? That use forwarding traffic destined for WAN IP of the MX on a specific port to any IP address with a local subnet. So that is important. That is important, that your WAN IP of your MX is forwarded to the local subnet. Okay, and once you create this rule, then it will be clear that what is your uplink. So you need to specify that my uplink is Internet 1 or Internet 2 or both, what protocol, what is the destination port, LAN IPs, all these things you have to define. And here is the specification about all these um, ports. So for example, suppose if I'm allowing port 111, so that is my local port, say 113, this is my local LAN port, to public port, and with respect to TCP 111 to 113. So that means I am not translating my ports. Okay, so if you simply wish to follow the traffic without translating the port, it's okay. But suppose if you want to translate with say 222, say 225, so that means what will happen, your port number 111 will translate to 222, port number 112 will translate to 223, and 113 will translate to 224. So you should take range from here to 224. Okay, and that is the clear description here. So if I am translating from 222 223 to 225. So 223 will convert to 628, 224 will convert to 629, and finally 225 will convert it to 630. Okay, so this is the flat rule we have. Let me go to my section, lab section. Here, if I click here, testing, yeah, both the uplink I am using. My port, public port is say 222, LAN IP is say, here I can take 20, then port, and then the remote destination. Okay. Likewise, I can give and I can add the rules. I can delete the rules as well. So here I can add the rules. Okay. And if I want, I can delete. So for all those things, this description will be very important, that uplink, protocol, public port, LAN IP, local port, what is the allowed remote IP addresses. In allowed list, we can have IP address or range of the permitted IP addresses, okay, for that forwarding rule. So all these things we can do. Simply we can uh, forward the ports in this rule. Now when it is coming to NAT rule, we have two type of NAT rules supported here. One is one to NAT, one-to-one NAT means A will map to B, and second one is many to one. So many of the client will be mapped to one of the destination, and then rest of the client they are mapped to the other destination. Now sometimes it is referred as port address translation, we'll check that. But this is the overall concept of NAT, that you are translating either one to one or many to one. Now for this translation, what you need, I need WAN side IP address, and I'm translating that to the local address. What are the things I need? I need public IP, LAN IP, what uplink I'm going to use. No problem on that. We can easily do that. But only thing you have to think in your mind, that while we are doing this translation, means once we create the rule, that does not automatically allow the inbound traffic to the public IP, okay, because by default all the inbound connections are denied. So this is very important. So suppose if I created the rules, that doesn't mean that it will start translating the addresses, but for that you need to allow the inbound connection. Okay, so this list you need to allow, otherwise the traffic will not start translating. Let me show you in the graphical mode, because it's very easy to configure. Here you can click to one NAT, and then you can give the name, the public IP. So for example, I'll take any LAN IP, uplink, internet 1 or internet 2, no problem. So once I create this rule, that doesn't mean that it will work. For that I need to allow the connection. So what port I am using inside, what is my remote IP, okay, and likewise I can allow more connections. In protocols I can use TCP, UDP, ping, or any. So if I choose any, then there also I have any to this destination. Okay, so this is the power of Meraki dashboard, or the graphical interface. Everything we can do with simple clicks. Okay, let me go back. Then we have one-to-many, sometimes it terms as a port address translation. It is more flexible than obviously one-to-one NAT, because one-to-one NAT all the time you have to create a long list. Here you don't need that much. So what are the things I need? I need one public IP address, the uplink, and then I can create the rule. So better I'll show you in the GUI mode. So let's go and check our graphical interface. And if I click one-to-many, then it will ask for what is your public IP uplink. I can use testing. What is my public port? The LAN IP. What is the local port? Allowed remote addresses. Okay, so here I don't need anything to allow, because here you need allowed inbound connection. Here the rule construct is easy. Simply you can click one by one, and we have option for TCP and UDP, and we can create the rules. Okay, so you can see that it's not that difficult. We can easily create the rules without any hassle. Now finally we have the bonjour forwarding. What does it mean? So if you want, and this is the second portion. So if you want to allow the rule that will work between VLANs, then we need this. Okay, so what does it mean? Let me go to the graphics. That once you enable this bonjour forwarding rule, then enter VLAN. And what I can do, I can select my service VLAN, say my, let me check data. My client VLAN is also data, and what services I want. So I want printers, and I want scanners. That's it. Okay, so once I create this bonjour forwarding, then service VLAN to the client VLAN, the services, these services will be intercommunicate. Okay, so now you can see what is the power of this particular firewall section inside this security appliance. Inside firewall, we can do layer 3, layer 7 filtering, then we have port forwarding options, then we have NAT rules, then we have bonjour forwarding. All these things we have, and this is only one section of the security appliance. We have already discussed about the traffic shaping, content filtering. So in the upcoming session, threat protection I'm going to discuss in the next recording, and then we'll move to some other sections. Okay, so I'm going to close this, and I'll see you in the threat detection. Next topic is advanced malware protection. Meraki, they have integrated their security appliance with AMP, and that is giving Meraki a great, or a cutting edge over other SD solution. So if we integrate Meraki with this AMP, what are the things we can do? Obviously, we'll check in this particular session. But once we integrate, there are two important concepts with AMP. One is the disposition, other one is retro inspection. Okay, what is this disposition? While doing disposition, we can categorize the files in three categories. Either it is a clean, or it's a malicious, or unknown. If it is clean, then obviously it can be downloaded. Malicious, then we can take action. Unknown, again it can move to the retrospection. Means what action you can do on this. Either you want to reclassify it as a malicious or as a clean, because for such files you don't have sufficient information, then you are thinking this as unknown. Okay, Now, obviously, if it is something that you want to reclassify these unknown files, you can reclassify it, and if it is clean, then it will be downloadable. The proposed Meraki MX Cloud Managed Security Appliances will block HTTP-based file downloads based on the disposition received from the AMP. So disposition means the three things: either it is a clean, malicious, or unknown. So according to that, it will take action. Now I have a task here that I need. If what are the steps to enable the AMP in my system? Also proceed to enable intrusion prevention and enforce a balanced rule set. So how basically I can enable this AMP and IPS IDS system in my security appliance, that will check. Let me go to my lab dashboard where I have my security appliance. For that, I can go to threat detection. So security appliance configuration, not this much, yeah. Threat protection. So once you are inside threat protection, then we have two options here. You can see AMP and IPS or IDS. IPS IDS will check in the upcoming recordings. Mode, it is asking when enable, all HTTP traffic will be analyzed for malware. Files determined to be malicious will automatically blocked before they reach the client for a destination of the file evaluates. If you click here, you will get this support page where you have all these documentations. Let me enable this. So once I enable this, now you can see that after enabling AMP, what are the things enabled here? The whitelist URLs, whitelisted files, threat grid, and this is actually important. What is the rate mode for threat grid? Now let me go back to my slide, and here we have this threat grid overview. Cisco has integrated with this threat grid, a malware analysis platform. What it will do, it will perform automated static and dynamic analysis, producing human readable reports with behavioral indicators for each file submitted. So we have the grid report, and where it will perform automated inspections. Threat grid global scalability drives context-rich information that can be consumed directly or via content-rich threat intelligence. So all these things you can see that in firewall we have studied about layer 3 inspection, layer 7 inspection, and some of the NAT rules. Now here we are inside the threat, we are inside the threat container or threat protection engine. So inside this container, not only we can enable the AMP to do the malware detection or prevention from that malware signatures, but we can do the IPS IDS as well. So you can see that how powerful this Meraki solution is. Threat grid analyze suspicious files against more than 950 behavioral indicators and a malware knowledge base source from around the world. So all these things, you can see how important all these things are, because these things we can't host in our infrastructure. We need a global cloud where all my datas, they can be analyzed, and that database should be automatically updated. So if new threat is coming, my cloud infrastructure will automate itself, means it will update itself with the new signatures, and then it will provide the solution. And again, this is the overall goal of the cloud solutions, that you are not overburdened with all these things. Okay. And now the important things here about this threat grid that they can do deeper insights into what malware is doing or attempting to do, accurate identification of the threat, proactive protection for business using threats intelligence, defense against threat originating anywhere. So these four important parameters we have, that deeper insights, accurate identification, proactive protection, defense against threat. Okay, and that is the use of AMP and this threat management engine. So once I enable that, I can click here to the mode, enable or disable. Then I can do the rate limit. So if I enable the rate limit, then again it will ask that, okay, restrict this network to 0 submissions every day. Okay, so it depends on our security, global security policy, what is our corporate security policy, that how we can use this. Now after that, here you can see that we have other options as well, that what is the white listed URL, what is the white listed files. And if I click here to the knowledge, URL matching, those in the list will be excluded from malware scanning whitelist. So what happen actually, that suppose if you have any false alarm, if there is false alarm, that means my security appliance will block that traffic. So on those cases, we can find the URLs, and this will be the manual attempts. So we can list the URLs that will be blocked with the false positive, and then we can add those URLs inside the whitelisting. That is the one thing. Second thing, whitelisting IDs for files such as JavaScripts and other objects that are not URL. The MX appliances assign a unique ID, and then we can list those unique ID there. Okay, so even you can see that how user friendly this is. Obviously all the GUI interfaces are user friendly, but this is one of the most user friendly engine we have, where simply we can put these things, we can enable these options, and it will be applicable widely anywhere. So here we can give URL and then comment, and in the whitelist file we can give the ID number and then the comment. And if we don't want all these things, we can simply delete it. Okay, so this is the AMP, that how we can enable AMP and what are the other models we have with the AMP. In the next section, we'll check upon IPS IDS. Our next topic is intrusion detection and the prevention system. What does it mean if we are using MX, that is our security appliance, in intrusion detection mode? That will detect and generate log. And suppose if I use this as a intrusion prevention system, then at that time they will block it automatically. So let us go to our slide and check all these stuffs. What we can do in case of IDS, so we have IDS and we have IPS. IDS will generate log and it will block. Means what we are doing in case of IDS, that we are placing this IDS somewhere in line to a network, and then they are start collecting all these informations. Once the IDS sensor will sense some anomaly or detect some unlegitimate signature or some exploits, then will we then they will generate a log, and with help of any third party IPS IDS system, something like Snort or anything, or any server, means we can send those things, send those logs to some server where our engineer can monitor all those things, and then they can take appropriate action. That is the IDS case. But in case of IPS, obviously it will block, means it has the capability to block the traffic, drop the traffic likewise. Let me first discuss about this IDS system. IDS system, you can see here in your slide that this way we can enable, no problem, we can go and enable. Once we enable it, then we have three distinct rule sets. First rule set is connectivity, that will contains rules from the current year and the previous 2 year, and its CVSS score is 10. What is this CVSS? CVSS is nothing but the common vulnerability scoring system, and suppose if it is 9 to 10, that means the vulnerability is critical. If it is in between 7 to 9, it is high, medium, low, like that. So it's something like we are providing a rating to different exploits, and according to that they will work. Let me go back to my slide, and here, so that is one rule set. Other rule set, that is the by default enabled, means once we enable the IDS, balanced rule set will be enabled, and that CVSS score is a score of 9 or greater. What type of category it has? It has malware CNC, that is rule for known malicious command and control activity. Blacklist means rule for URIs, user agent, DNS hostname, and other IP address that has been determined to be indicator of the malicious activity. SQL injection, exploit kit. So just if I summarize all these things, these things are very much related to the CEH course. If you do certified ethical hacking course, then there actually you have to do some hacking stuffs, means you are trying to search what is the operating system vulnerabilities. Say in 11 what was that, in 12 what was that. Even with help of some tools you can do SQL injection or some database vulnerability exploits. You can explore the kit. Is something like rootkit or some other exploits. Then obviously malware is there. This thing already we have discussed in case of advanced malware protection, but is still in the same place. We can detect this malware command and control activity in our IDS systems as well. Then the blacklist. So not only the IPS or IDS systems, they are tracking in terms of the signature, exploits, different database injection, but they are monitoring the network or the profile anomaly as well. And these are one type of activity on that. Okay, so if they are detecting any abnormal behavior or collecting data related to that, if any abnormality in terms of network, in terms of profiling, in terms of other protocol signatures, then they will detect that. What is the third? Yeah, third one is the security rule set. In security rule set, everything that mentioned in the balanced rule set, that will be applicable, plus they will add app detect, means rules that look for and control the traffic of certain application that generate network activity. Yeah, all these things you need to do research, means what type of exploits, all these things, because all these exploits have their what you can say, have their background and have their generations. So you can check the background and the generation for all these things. By default, we have this balance rule set enable. No problem on that. Next is the intrusion prevention. So before covering intrusion prevention, let me go to my dashboard, and here I am inside security and then the threat protection. In the threat protection, we have this section that intrusion detection and prevention. I can run this in a IDS mode, or I can run this in the IPS mode. By default, it is balanced. If you want more detail, you can click to this URL and you will get the more detail on that. But we have options connectivity, balanced, and security. So let it be like balanced, and we are done. Let me go back to this slide. Now, if we run this in IPS, intrusion prevention mode, then not only they will track, but they will automatically block if it detect malicious activities. And obviously all those activities that we have studied in the last section, they will start blocking all those things. Okay. If you want to view all this information, what you can do, you can go to security appliance monitor and then the security center. The report will provide you a graphical representation of IDS events in your network. The security threats are broken down: signature anomaly, network anomaly, client breaches, and you can filter all these information. Okay. So let me go to this place, and if I want to run this as a IPS, simply I can change the mode to IPS and then the balance mode. If you just want to see all these information, then you can go to security center. Means from security appliance, you can go to security center, and then you will get the graphical representation of all those things. Even you can download, you can email. Okay, so all these things are possible. Okay, then I'm good to cover up all these security aspects. Let me close here, and then in the next section I will start with VPNs. Let us start site-to-site VPN inside Meraki boxes. For site-to-site VPN, as long as we have IP reachability, the site-to-site VPN will form. In our Cisco World technology, we have seen this, that okay, if you want to form site-to-site or LAN-to-LAN VPN, then this device must know this peer address, and this device must know and have reachability to this peer address. Once you have this reachability, then you can use phase 1 and phase 2 negotiations, and then your VPN tunnel will start working. For that, obviously we need some ACLs to map what interesting traffic is flowing over VPN traffic, and that's it. Now, to do all these things in Cisco World, what we need to do the manual configuration. So we need to configure phase 1, phase 2, then we need to create crypto map and all these things. In Meraki World, we don't need such complexity, because in Meraki only just with few clicks it will happen. Okay, so all these phase 1, phase 2, routing, negotiation, everything will be happen with the GUI mode, just with a few clicks. In Meraki, they are also using phase 1, phase 2 like this. Here you can see phase 1, where the encryption keys are AES 128 to 256. Apart from that, we have option for days and triple days. For authentication, it can use MD5 or SHA. For Diffie-Hellman, it can use group keys 1, 2, or 5. Remember this, is something called symmetric encryption. This is something called asymmetric encryption. And finally, we can give the lifetime for phase 1. Phase 1 is nothing but the ISA Kemp policy, Internet Security Association Key Management Protocol. And generally it is, we think that phase 1 is nothing but the framework. So we are creating the framework that this framework will used by phase 2 to send the actual data. And the phase 2 is what? Phase 2 is something IPsec negotiation. IPsec negotiation, again, it will use encryption, authentication. This is added security in IPsec phase 2, where they are using perfect forward secrecy. And again, it will be Diffie-Hellman 1, 2, or 5 group keys plus the lifetime. Okay, so very much what we have done in Cisco normal VPN networking. So theoretically or conceptually, things are same, but while we are configuring it in Meraki, we'll do the configuration with help of few clicks, and in Cisco world we are using with the CLI. Once you form the tunnel, then how you can monitor it? For that, we can go to appliance, monitor, and VPN status. We'll check that. And suppose if you want to apply some firewall rules, some L3 firewall rules, that okay, I am sending traffic over my auto VPN. So I have my auto VPN across data center and branches. So I can use L3 firewall rules to filter those traffic. Okay, and where we can do that, let me go to the dashboard, and from security appliances we need to go to site VPN. So once we reach to site VPN, if I scroll down, then here we have this option for firewall rules in the outbound and the inbound directions. Okay, and all other parameters will check in the upcoming recording. But yeah, if you want to monitor, then you have to go to your security appliance, monitor, and then your VPN status. So once you click to VPN status, we'll get the VPN status for this particular data center. This is data center secondary. And let me quickly brief you that what type of topology we are using here. So my topology is that I have one DC1. This is my DC1, DC2, and then I have two branch. Say branch 1, branch 2. The moment I am here at DC2, so it is showing that it has VPN connection like this, and one connection here, and one connection here. It is something like hub and a spoke type of connection, where this is my hub and these are my spokes. And here you can see that I have tunnel with primary, I have tunnel with branch 1 and branch 2. Say if I go to any of the spokes, say one of the branch, let me go to the branch Elkton, and there also will go to the security appliances VPN status. Now here it is showing 4 tunnel, but this is the overall tunnel. We need to filter out. So for that I need to click here to a particular branch. Now this branch is showing that okay, oops, my diagram is gone. So this branch is telling okay, I am your branch 1 and I have VPN tunnel with DC1 and with DC2, like that. Okay, so again this is hub and spoke type of configuration, and likewise we have the same auto tunnel with the branch 2 as well. So branch 2, if I go and if I check that it has one tunnel in this direction and one tunnel in this direction. Okay, so for DCs we are using 3 VPN tunnel, and for branches we have 2 VPN tunnels. So let me again go to say DC primary, and let us check overall how many tunnels we have. So if I clean this screen, you can come to know that okay, for DC primary and secondary we have 3 tunnels, because one tunnel is from DC1 to DC2, but for branches I have 2 tunnels and I'm using 2 subnet. I'll show you that what subnets we are using. My subnet is one subnet is for data, one is for voice. So two subnets at the branches, because I have 2 VLANs at the branches. You can check the latency. And if I have non-Meraki peers, then here we'll get the description for that. In our labs setup, we don't have any non-Meraki peers. Okay, so let me close here, and in the upcoming recording we'll check the VPN settings and the phases that will be used for the Meraki devices to build a VPN. Let us discuss more about this site-to-site VPN in the Meraki world. So once you are creating the site-to-site VPN, then what Meraki devices will do, that they will advertise its local subnet. That's the first thing. Second thing, advertise its WAN IP address to whatever internet ports we have. It will download the global VPN route. It will download the pre-shared key for VPN negotiation. So all these 4 steps they are doing once we are clicking and once we are enabling the VPN. Now the important thing here, that what mode of VPN we want. So what does it mean? That I have one Meraki device, say here, MX, and over the cloud I want auto VPN with one of my branch, say branch 1. Now we have option. Either we can run this VPN in the off, means we don't want VPN. Other option, we can have VPN in full mesh. So if you want full mesh topology, and you know that full mesh means all the nodes can talk to all, something like that. Or if you want in the partial mesh or hub and spoke. In our case we are using hub and spoke just to reduce the number of tunnel endpoints, but we'll check what are the limitations and use cases for all these modes. And, for VPN that is running in the hub mode, we need to run all the devices in the hub mode. So whatever devices in the data center or in the branch, you have to check this box. Means if you want full mesh, then everything should be in the hub mode. That is the one condition. Okay, let me go back. So how we can configure that? You can go to configure site-to-site VPN page. There we have option of hub spoke, and in our case we will use hub and spoke. I will show you that, no problem on that. So let me go next. Say if we are running this in the hub mode, so in the spoke also, means I have my data center, say is in hub, and my branch is my spoke, but it is running as a hub. So on that case, what will happen, because in this case everything is full meshed. When configuring hub for a spoke, there is an option to select the hub as being a default route. If this option is selected, then that hub will be configured as a default route to the spoke. So what does it means? That if you have default route, means if you are running in the partial or if you are running in the full mesh topology, at that time you need to install the default route. So what will happen with this default route, that any traffic that is not sent to a configured VPN peer, a static route or local network will be sent with help of default route. So any traffic that will not fall under this VPN traffic, those traffic will use the default route. So that is the use case. But while we are using VPN in the hub mode, then the other options, that to add additional hubs, yeah, we can click, and there is check box, you have to click add another hub, and you will get all those things. Please note that only appliances in the mesh VPN, yeah, that we know that if we are running VPN in the mesh mode, all the appliances should be in the hubs, the mode should be in the hub. Okay, so another one important thing here, that the uppermost hub, that is advertising the subnet and currently reachable via the VPN, will use to reach the subnet. It's okay. Thing is that either you can in the full mesh, either you can uh, send the traffic over VPN, or you can use the default route. If the traffic is not fall under VPN, you can use the default route. That is the whole concept here. So let me clean this and let me go next. Then we have the tunneling options. Either we can use a split tunnel. A split tunnel means that all the traffic is not inside the VPN. So some traffic you can send with help of VPN, or those traffic we are not falling under VPN, then you can use some other routes to reach there. Okay, so instead this traffic is routed using another available routes, and that is the key point. But suppose if you're running the VPN in the full tunnel mode, so at that time all the traffic will be under VPN. So that is the difference. Either we can run in the split tunnel or we can run in the full tunnel. So let me show you our VPN setup in the hub side and in the branch side. So at the moment I am here in the data center, and we know this that my DC, say for the sake of simplicity, I have only one data center, and I have two branch 1, branch 2. So we are going to check the side to side VPN type in all these three places. Okay, so here in the data center it is running as a mesh or as a hub type. Now let me click and go to my branch. So if I go to my branch, say Elkton, and simply you have to select and go. Now here it is running in the spoke, because yeah, we are using hub and spoke topology, and here we can add the hub. So for this you can see the default route is enabled. The first one is my primary data center, the second one is my secondary data center. If I want to alter this priority, what I can do, I can simply drag and drop. So now the first is the secondary data center, second is the primary data center. Okay, so when we are running in the spoke mode, then we have option that we can add the hubs. Likewise, let me go to my final branch, that is the case. I click there, and you can see here in the case also we have the same, but here the secondary is first priority and the primary is the second priority. So again, it's very interesting here that we can check that for this data center, because I have two data center. So for this particular data center, it is thinking that this is my primary VPN and this is my secondary VPN, but for other branch, this is secondary and this is primary. Okay, so you can see what flexibility we have while we are at the spoke, and the spoke can choose primary, secondary, secondary, primary. Something like we have done in the case of load balancing as well. It's something like we are doing some sort of load balancing to the data centers with help of simply drag and drop. We can give who is my primary tunnel and who is my secondary tunnel. So let me close here, and the next section will check the other VPN settings. Okay, let us discuss whatever left over in the previous sessions. We can run our VPN in the concentrator mode. The only condition we have that it should be in the mesh. So VPN should be in the mesh mode while running this, and the list of the things that they will do are the same that in case of that we are defining the hub priorities. Means they can advertise the subnets and they will be reachable with the default route. Okay, because we know that in pure hub or in pure mesh topology we need default routes as well. Okay, so that is one mode we have in the VPN. Now while we are enabling the VPN, suppose if my devices are behind the NAT device, or say if they are behind the firewall. So on that case we have option that we can run our VPN in automatic mode, means automatic NAT traversal will happen, or manual port forwarding is the option. Most of the cases this automatic will work, but suppose if the automatic feature will not work, so at that time we can use the option that is the manual. So here in this case we are using this automatic, but suppose if it will not work, then obviously we can use the manual forwarding. Apart from that, we can assign local network. So here you can see that in my branch keys, so I have two branch, and in branches I have two subnet, one for voice, one for data, voice and data. So in the keys branch for voice I have subnet 10, 30, 11.0, and here I have subnet 1030, 10.0. Likewise, in the Elkton branch, I have subnet for voice 10, 20, 11, and 10.0. So here you can see that we have option that we can add the local network. We can give the remote VPN participants. So for this branch, these two subnets we have 10, 2010 and 2011. For DC1 or DC primary, we have 10.100 subnet. For DC secondary, we have 10.200 subnet. So for primary, we have 10.100, and secondary, we have 10.200 subnet. And we have this VPN tunnel that we have already seen in our VPN monitoring status. Okay. So all these things will be there. Yeah, local network we can add. Apart from that, we have option that we can do the OSPF things as well. So let me go to my primary data center. And why we are using this OSPF, you can see that MX Security Appliances does not currently support full OSPF routing, but is still OSPF advertisements only supported in VPN in the concentrator mode. So if we are running VPN in the concentrator mode, then this OSPF advertisement will happen. But why we need OSPF? That if you want to advertise, means if you don't want to use the static route or the manual routes, so at that time we can use OSPF, and whatever features we have inside OSPF, like in Cisco world, we are giving router, OSPF, then the process ID, and then we are advertising the network. So likewise, we can define all the features related to OSPF. Let me show you that. So here I am in the data center 1, and if I scroll down, you can see here that I can enable or disable OSPF. So once I enable, then I can give the router ID, area ID, cost value, hold down, date timer, message authentication, and then I can give key and the password like that. And here also you can see that advertise remote routes, router ID, area ID, cost, date timer, MD5, authentication key. All these things we can define. Okay, so in this way our system will be up and running, and we have seen all those stuffs. We have checked that, okay, site to site VPN, what is meaning of type, what is that VPN setting, local network, NAT traversal, then the remote VPN participants, OSPF setting, what is the organizational wide settings we have, means are we running this in the concentrator mode, if we want to allow some traffic or disallow some traffic with help of firewalling option inside VPN, we can use this option as well. So all these things we can use. Let us discuss this non-Meraki VPN peers and then we'll wind up. So suppose if we want to create IPsec tunnel between Meraki and non-Meraki devices, so at that time what things we need to consider. Obviously we can create it again, the same place we can go and create that tunnel. We have to define the name, public IP, subnet. If you want, we can give a static routes, the IPsec policy, the pre-shared keys, and finally availability settings to determine which appliances in your dashboard organized will connect to the peer. So that means that we need obviously the peer address, what will be the public peer address, then IPsec policies, pre-share key for page 1, all these things, and we can connect our non-Meraki devices to Meraki.
Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCIE data center 3.0. Those are the new uploads as well. So please go continue your learning, take the coupon, enroll my courses, and study well. All the best.
Welcome everyone to our Cisco Meraki step-by-step troubleshooting course. In this particular course, I will show you a step-by-step how you can troubleshoot various Meraki related issues, say issues related to DHCP, issues related to IPsec, automatic NAT traversal, issues related to client speed and traffic shaping, issues related to say packet loss between the devices. In this particular video series you will find that how you can do the packet capturing, because one of the greatest feature we have inside the Meraki dashboard that you can do the packet captures, and once you do the proper packet capture at proper point, then you will get all those information, and you will get all the information related to who is causing the trouble and what is the trouble, and then further you can go for the solution. Okay, so this is the course agenda you can see here, and I hope this particular course you will find very informative. In this section I am going to walk you that how you can do troubleshooting with respect to client side DHCP. Okay, we know that what is the DORA process, that is the discover, offer, request and acknowledgement. Means first time the client they are sending the discover, then from the server is offering the IP address. If client is satisfied, then it request, okay, I am fine with this IP address, and then finally the server it is sending one acknowledgement. Once the client and server they complete this negotiation in terms of DORA process, then we have the IP address assignment at the client level. Now suppose in this process your clients they are not getting the IP address from the DHCP server, or suppose if they have some issue related to DHCP server, then how we can do the troubleshooting? The simple way here is to do the troubleshooting. So suppose this is your client, it is connected to switch somewhere, then somewhere down the road you have your DHCP server. What you can do, that you can do the packet capture at client end, you can do packet capture at the server end. Here we can see are you getting the DORA packets, means discover offer packets. Here we can see are you getting the offer packets. So if we see this, what type of packet the client is sending, the client is sending something called DORA. That means it has its own MAC address, and the destination MAC address will be OLF, means because this is a type of broadcast packet. Now at the level of DHCP server, while you are doing the packet capture at the DHCP server, here also you can see that I am getting the MAC address of this client or not. Okay, so this client can see that I am getting the MAC address of server or not, server can see that I am getting the MAC address of the client or not, and then in this way you can compare it and you can find it where that particular DORA packet or where that particular DHCP packets are dropped. Okay, we'll check this. How to do this packet capture? It's very easy. You can go to monitor and then packet capture, and you can start the packet capture. Now you have the option that you can choose .pcap. By default it will be there for 60 seconds or 5k packets. Then once you do the capture, you should have your Wireshark in that local machine where you want to analyze the pcap. To generate the pcap packet, what you can do, that from the client side you can do ipconfig release, ipconfig renew, so it will generate the broadcast packet, that will be the discover packet. Means you need the discover packet to be initiated from the client. So once you initiate that discover packet successfully, then in the packet capture you will find these things. Now very important thing here to remember, that you can filter that packet capture with boot P. So if you do that boot P, then you'll find that okay, I am sending a broadcast packet, offer is happening, request is happening, and then finally I am getting this particular IP address. This transaction ID is actually very important. We'll check that why it is important. So this process will happen. If this process will happen successfully, that means I am getting the IP address from the DHCP server. Suppose if this offer, request, acknowledgement, all these things will not happen, that means we have some problem. Okay, so what problem we have, we'll check that. Means the client will not get the IP address, and how you can validate that. So validation process is this, that you know what is your MAC address, correct? So you can validate your MAC address, means the client MAC address, then you can validate the server MAC address, and then you can cross verify these MAC addresses. That is the validation check in this DHCP process, the communication between the client and the DHCP server. In this actually we have two common problems. The first problem is the client device never receive a response from the DHCP server. So I am sending D, but I never get O offer. The other problem, the client device gets an IP from the rogue DHCP. This is also very important thing. Means you are thinking, oh, I am getting the IP address, but still there is some issue in the network. That is cause of this rogue server. Okay, so for this, say the problem number one, what you can do, that you can follow these steps. So first of all, you can verify that you have proper 802.11q is there or not. You have proper VLAN allowed on the interfaces or not. These two things related to VLAN and encapsulation. Then what you can do, and this step is actually the core of this troubleshooting, that run a packet capture to all the devices. So what does it mean? I have one server here, it is connected with one device, it is connected with one device, and then finally I have my DHCP server. So what is the recommendation is that run packet capture at DHCP server, run packet capture here, run packet capture here, run packet capture here, because by the end of the day you need to find the offer. So you need to find that although I am sending the discover, but I am not getting the offer, which point it is blocking. Obviously in the packet capture you will come to know, and you will filter with the boot key keyword. Okay, so these things are very important. Once you verify the packets inside the packet capture, then you have to check what is the source MAC and what is the correct destination MAC. Okay, then finally what you can do, that you can check is there any routing issue in the network. Then you can check finally that is there any problem with the DHCP configuration. So is there any problem with the DHCP lease time? Is there any problem with the DHCP pool addresses? Is there any problem with the DHCP services? Means that services is starting and then stopping by default in the DHCP server. Okay, so all these things you have to check one by one for the problem number one. For the problem number two, what you can do, that inside packet capture you will find so many transaction IDs. So here you can see I have transaction ID end with 6, end with 8, 6, 8, 6, 2, 2, like that. That means I am getting this offer from so many other rogue DHCP servers. Okay, so you can think that your packet capturing things are your primary tool, but only caution here is to where to do the packet capture, and once you do the packet capture, how you can filter that packet capture. Let us discuss about automatic NAT traversal for IPsec tunneling between Cisco Meraki peers. Now this is the big subject name we have, but the concept is easy. What is the concept? If we think or if we talk about any of the SDN solution or particularly SD-WAN solution, what is happening in SD-WAN solution? We have control plane somewhere, okay, and then we have data plane somewhere. But in between control plane and data plane we have some sort of connection, and from one data device to other data device we have some sort of connection, correct? This is the whole idea of any SD-WAN solution, irrespective of Cisco or Juniper or say Silver Peak or Versa or Velo Cloud, whatever. We have segregation of control and the data plane. Now how control plane will instruct the data plane to form their IPsec tunnel, that is interesting thing that we'll learn here. Let me go to the slide number 2. Here in this case we'll learn that actually we have two types of steps or phase. So phase 1 is something registration phase, phase 2 is connection phase. Means all the data plane devices, they will register to the cloud, to the Meraki cloud, that is phase 1. Phase 2, then that cloud will allow data plane to form the IPsec tunnel. That concept is actually UDP hole punching. Okay, so let me go step by step or slide by slide. So automatic NAT traversal, that is the recommendation from Cisco, because what we are assuming that we can't connect our devices directly to the public cloud. It should be separated via firewall and NAT. So that is the need here, that suppose if you want to form auto NAT IPsec tunnels, because your devices are segregated or separated due to this firewall or NAT devices, then this is the recommended thing in Meraki. You can use that. How you can enable that? That's very easy. You have to go to the security appliances. From there you can go to site-to-site VPN. Once you are there inside site-to-site VPN, then you can configure site-to-site VPN. You can choose this option, say automatic. Okay, and this is in between two Meraki devices. Okay, now what phases we have? We have already discussed that. We have registration and connection page. They are using UDP hole punching. If you want to learn more about UDP hole punching, then you can refer the RFC number 3027. There you will get the document. There you will get more information about this hole punching. Here we'll see that how this process happens. So what happens in, say, registration phase? In registration, say phase 1, what is happening, that these devices behind this firewall, they are sending, you can say, some sort of request, but this is some sort of registration packet that is going to the cloud, and they are using port number. We'll see that the port number recommendation. So suppose 35K, it is using that port number. That is the source, and the destination always that will be 9350. That means inside your firewall you need to allow those ports, otherwise the registration phase will not happen. So from 333 and 35K, it is sending that request. From, say, 444, here in the outside of this firewall, it is sending that request. That means my cloud is learning these addresses and these UDP ports, these addresses and these UDP port. That is the registration phase, phase 1. Now once my cloud will learn these things, what the cloud will do, here you can see, now it will tell this particular device that this is your destination port and UDP number, and this device that this is your destination port and UDP number. So destination IP and UDP number. Okay, destination UDP port and IP numbers. Okay, so this will complete the phase 1. Now suppose if you have any issue, any problem in your network, and suppose if you see that your VPN status is red means bad, is not forming, VPN is down. So first of all you need to check that the registration phase is happening or not. Okay, so let me go to the dashboard, and where we'll check this first. Let me log to the Meraki devices. Logged in. What you can do here, if you want to check the status, you have to go inside appliance, monitor VPN status. Here you can see it is green, means okay. I have the primary and secondary VPN, say, over my data center. That's okay. Now where you can see the registration phase, in this section you can see the phase 1 or the registration phase is completed over UDP port number 9350. Correct? So this is the way that you can check your registration phase. Now suppose if any problem is there, any issue is there, obviously you have to do packet capture, and in Wireshark you can open that packet and you can check that is my devices, they are not able to reach to the cloud. If they are not able to reach, you will get a red mark here. Even in the packet capture you will get that you are sending the packets, but you are not getting reply from your cloud. That means that your phase 1 is not happening. let us go back to our PPT. Okay, so once this phase 1 will happen, then we'll check the phase 2, that is the connection phase. Connection phase, at the moment both the devices, they know what is the public address and the UDP port number to their destinations. Okay, so they know that peer is located behind the firewall. These outbound packets create a session. Let's check here in the diagram. Okay, and before going to that diagram, just important note here, because I told you, say you have control plane and you have data plane devices. So data plane device 1, data plane device 2, they will form the IPsec tunnels. Even these data plane devices may be at data center. So this is a branch 1, this is a branch 2, this is my data center. They will form IPsec tunnel, no problem on that. Suppose if you have rule to branch IPsec, then they will form the tunnel. Otherwise all these branches, they will form the tunnel with DC say 1, DC say 2, and then this tunnel will not there branch to branch. Okay, so actual data is moving inside the data plane devices. Only you are getting the control information, where in this case the VPN destination, or you can say the destination public IP and destination port number, this particular cloud is sharing across the devices. That is the registration phase. So actual data will always move inside the IPsec tunnel. That is the important note here. So let us go to our photos here. In the pictures you will understand more. Inside connection phase, what is happening? First of all, obviously my AP know what is the source IP, and from the, let me draw here, from the cloud it knows what is the destination port and public IP. Now it will send one packet, the outgoing packet. The outgoing packet means in the destination packet you have this UDP port number. It is going across the firewall, it will cross the internet, it will reach here. When the UDP packet reaches SF firewall, it dropped because SFMX has not punched its hole. So in this particular firewall we don't have that hole, so it will first drop the packet. And important thing here to note that here your NAT will happen and you have NAT table, okay, for this particular destinations. Destination means you have one session. That's important. That is the one marking point here, that it will mark. Obviously the packet is dropped. Now what will happen? The other packet will come from this side, from SF side. Now SF side also, here also you have one session for NAT, but when this reach to here, that is the wake firewall, at that time what will happen? When the UDP packet sent from say SFMX packet arrive at the OAK firewall outside interface, it matches a previous established outbound session in the NAT table, so it forward the packet to the LAN. You got my point? So this is very important to understand. The initially you have one way communication, but the whole idea here that it will create one session. So I have one session here inside my firewall. When the request come from the other side, so at that time, because it has session, it will match that session and then it will allow the traffic to the OAK AP. Great. And now you can see that here also we have hole in firewall, here also we have hole in the firewall. Now in the final stage what will happen? Now from OAK to say SF firewall, what will happen? The AP sends a second UDP packet, okay, to this side, obviously with the same destination IP and the UDP port. Again the firewall rewrites the source IP address because it has to change the NAT session. So it refresh the NAT session, it will rewrite the packet, refresh the NAT session, and then it will send here. Okay, and now we have one active IPsec tunnel over UDP. Okay, so here you can see that we have many touch point. One touch point we have to the cloud in the registration phase. So once you do the PCAP or the packet capture, at that time if you have any issue related to port number 9305, that means that you are not able to 9350, sorry, so that means you are not able to open that session with the cloud. That is the one thing. Both ways you should have registration phase completed. Then it is coming to the connection phase. Now connection phase, so you can think that you have touch point 1, you have touch point 2. In connection phase, from this side, if you are sending packet and the firewall rules are not there, then they will drop the packet, and this is bidirectional. From here also you need those rules inside the firewall, otherwise the IPsec session will never come up. So these are the things that we need to check. We'll see in the upcoming session that what are the things we need to check here while we are doing the troubleshooting. But these are the port numbers. You can see that the source UDP range from this to this, destination to reach to the cloud is 9350, and inside the IPsec tunnel we have these UDP port should be open inside the firewalls. Behind that firewalls we have our Meraki appliances. In this section I am going to show you that how we can do the troubleshooting with respect to phase 1, that is the VPN registry phase. Now what will happen in this case, that they will send the hello packet, means my peer devices, they will send hello packet say after every 10 seconds. This is the keep alive, but you can think like hello packet, and this 6 keep alive you can think as a dead timer. So they will send keep alive or say hello packet after every 10 seconds to the cloud, and if you multiply by 6 means for 60 seconds. So after every 10 seconds one keep alive. Suppose if they will not get any response, that means registry from say peer 1 will never happen. So once the registry will not happen, that means this particular cloud, it will not share those UDP and say public IP information to other peer, and the VPN will not form. Okay, now what are the probable cause for that? Say cause for that, maybe the firewall blocks the outbound traffic, say matching port number 9350 or any port in this particular range, say 32768 to 6100. This is one cause. Now because first time we don't know that what is the issue, only what we think that the VPN is not coming up, and then that case will come to our queue, and then we need to troubleshoot. So if we know that we have to troubleshoot say with respect to phase 1, that is the registry and connection phase, first of all we'll do the troubleshooting with respect to VPN registry phase, and the best way to do this is to take the captures. So take the Wireshark captures. Once you take the captures, then you will find, okay, I am sending the request say with this source port, with this destination port, and these are the UDP ports. I'm sending, but I am not getting any reply say at least for 6 packets, say 1 2 3 4 5 6. So after that I am not getting reply. That means the phase 1 will not happen, means the VPN registry will not happen. Now in the working condition you can see that after sending the keep alive or say hello packet, we are getting the reply. Okay, we are getting the reply. That means the registry will happen. That means the VPN phase 1 will happen. That is the one thing, that is actually the best way to do the troubleshooting in case of Meraki, that you take the packet capture. Suppose if you don't know that how you can take the capture, it's very easy in Meraki. What you can do, you can go to security appliances, click there to packet capture, then you will get option. Either you want to take captures flat, means here you will get in the bottom that from this drop down menu, either you want some text type of capture or you want pcap capture. Okay, further you can download this particular file and you can analyze this. Now important thing here to note that the maximum packet capture duration is 1200 seconds, and by default this will stop after 60 seconds or 5k packets, and those packets are actually more than enough to analyze the problem, because this is the phase 1 for the troubleshooting. So suppose if we are able to figure out that okay, my registry is not happening, that means we identify the problem. Once you identify the problem, you know what the solution. In the firewall, you need to open those port numbers. So all these port numbers that those are mentioned here, even in the last recording also I have listed that. You can cross check that. So those things should be open inside the firewall rule, then the phase 1 will complete. Now here are two very important filters we have, that while you took the capture, you want UDP packet and the rest you can negate. Okay, so I don't need say GVSP packet, I want only UDP packet. Otherwise the other filter is that you want to do the filter say with respect to source IP, destination IP, source port, destination port, and according to capture uh, you can take your own port, own source destination port and IP address, etc. So this is the first troubleshooting steps that we need to take if say VPN is not able to form. Then we'll check the peer-to-peer VPN section. Similarly, we can check the site-to-site tunnel problems. So what you can do here in this section, that you capture the packets at these points like here and here, and what you will find that you are not getting the responses like we have seen in the previous recording. So what does it mean that the firewall blocking the UDP port number ranging this, and then it is not able to punch a hole. So we know about the UDP punching. It's not allowing, or it's not creating any hole in this. Similarly, when the traffic is coming from peer 2, what is happening? The packet does not match a previous established outbound session, so that's why it is dropped. Because we know what is the concept, that it will send the traffic, and then at this end, at peer 2 end, the firewall will drop the traffic, and then it will send the traffic, and because it has the session, so it will create the peer-to-peer peer-to-peer IPsec tunnel. Now in this case, because the first packet is dropped, so that's why it is not creating the session. That means we need to take capture here, and then we have to apply the filters, and then we have to check the port number, what is blocking inside the firewall. You will get this disconnect message. In this case, in the dashboard itself, it will show up that the VPN connection is not able to form, means it has a status as a disconnect. Now what we can do here in this case, that we can create rules, say allow inside to outside, then the protocol will be UDP. Now here are two rules. One rule is like any to any, and then the destination is also any, and port is also any, means this is the default. Means this rule is something like we are allowing all the packets who has established the session, or we have this option that we can go for a particular IP address, and this will be more safer, much better than the upper one. So here you can see that the everything is same. Only thing we are adding the source IP, then the port number. That here also we have the port number, then the destination IP, and then we are allowing the inside to outside. Okay, so give some more specific addresses or the access list, or allow those rules inside the firewall, and then you will find that your peer-to-peer IPsec connection will come up. Suppose if you have requirement to check the throughput inside the LAN or over the WAN from one end host to the other side end host, at that time what you will do? Say if you are using some sites, something like speedtest.net or no, any other site who is hosted over internet, at that time it will not give you the accurate measurement. Why? Because internally when you are reaching to that particular server or that particular site, at that time you have latency, loss, jitter, etc. So the best way is that you use jperf or iperf. Suppose if you want to use graphical interface, then you can use jperf. It's a free Java based GUI, from where one side you can make as a client, one side you can make as a server, and you can send whatever type of traffic you want to test, like TCP, UDP or others. Okay, so this particular jperf is a great tool to measure the throughput across your LAN or WAN infrastructure. Okay, how to use it? Let me show you that how you can use it. Suppose I have this particular topology where I have, say, host A, client. It is separated to server, that is host B. In between I have AP, I have Meraki switch. Now what I have to do first, that I have to install jperf here. I have to install jperf here. Once I will install jperf both the places, so what you have to do, download the jperf, say for Windows, you can use Windows version, extract them, execute that .exe file, install it over system. Once you install that, then what you can do, that you can open, say suppose if you open that particular what you can say, the dashboard or the software, if you open, you will get this type of display. Okay, now here you can see that I have iperf mode like client. So this particular software or this particular jperf will work as a client or server, you have to choose. Then we have option for address, port, say how many parallel streams you want to check. Now important thing here, that even we have the category for TCP and UTP as well. So suppose if you want to check TCP loss, latency, jitter or UDP, you can check. Okay, here you can see we have the capability mode as well, the output format as well. Once you start that jperf, but first of all you have to establish the client and the source type of traffic or the mode. So from where to where you want to transfer the traffic or send the traffic, or you want to check that, then you will get a graph here in this bandwidth graph. Even in the output format you will get the output, that what type of filter you are using, and then same type of output you will get. Now say in our case what we'll do, that will make host B as a server. So this is host B I'm using, and I'm listening on this particular port 5001. Rest say everything I'm using as default. Okay, so choose protocol to use, say TCP. Buffer length you can say 2 megabytes. Window size is this. Max segment size or MSS is 1 kilobyte, like that. So once you use this, then you have to click here to jperf. So this filter will work. Once you use this filter, then you can see that it will show you the command line equivalence as well. So what is the command line equivalence for this? This is, so I am using -s -p I, port number 5000 FK, like that. Now we have set the server. You can set the client as well. In the meanwhile, if they pop up, you can just trust this Windows firewall. Okay. Now in the client side, you can see it's important to give the server IP. The port number is 5001. Yes, the host A is the client, and here the command line equivalence here. Okay, now you have to click run, say iperf. Now this will establish the session, and from here you will start getting the output or the throughput in the bandwidth graph, plus here in the output. So let me show you that as well. And here it is. You can see the transfer, you can see the graph. Okay, so according to your setting parameters, you will get this. It is set as a 2 Mbps. Okay, so here you can see 2 Mbps, and it is increasing, means it is peaking to some high rate. Again it is dropping, peaking, dropping, like that. And here in the output also you can see that 2, 1.96, 1.8, 2, like 2. So at the moment we can see that we are exactly getting the 2 MB of throughput. Yeah, little bit plus minus will be there, but we can see that this graph is touching. Okay, and this is the way that we can check that exactly if they are sending 2 MB, I am getting 2 MB or not. So this is one nice and easy way to check the throughput over LAN and WAN across the infrastructure. Packet loss is very common to any network, irrespective of Meraki or SD-WAN or any type of traditional network. We are experiencing packet loss, and users or clients, they are raising tickets related to latency or packet loss in the network. Now the good tool to determine packet loss is ping and trace route. So you can think ping and trace route as a primary tool in your tool belt, from where you can determine the loss in a network. Now this particular ping is because we know ping is a ICMP protocol, means it is sitting at layer 3 in a TCP IP protocol suite. Ping test doesn't mean that it is a legitimate test for any application, say latency. So for that you need some other uh, other things as well. Suppose if you have latency with respect to any application, such as say SAP or any type of application, so you have to check that in other perspective as well. But moreover, ping test will give you approx say 80%. So in 80% of cases, with help of ping and trace route, you will identify the problem and you will solve the problem. Okay, rest 20% belongs to some application or some what you can say, some third party protocols, third party applications. You need all those plugins to determine the packet loss or latency in a network. So you need to take packet capture, you need to install some third-party tools in the workstation, and then end to end you have to check all these steps you have to do. Okay, let us discuss about packet loss, and in terms of say ping and trace route, how we can determine it. Simple and easy way: you ping, you will find that you have some loss. Say here it is 40%. That means you have loss somewhere. Now at the moment you don't know that, say from your host machine, how many endpoints you have. So how many routers, how many switches, how many gateways you have in between, and in which segment you have that packet loss. So for that, what you can do, you can simply trace route. Once you perform the trace route, then what will happen, you can see here in this particular diagram, that once I use this trace route, first of all it will hit the client gateway. So whatever gateway that PC has, then it will reach to the ISP gateway, and then further inside ISP it will route, that packet will route, and here you can see I have one packet loss. Now this doesn't mean that you have loss, because maybe there are chances that this particular hop count is blocking ICMP, means it is not replying this echo request. So that's why we have a drop here. That's why we have these asterisks showing that we have drop. This is the example without loss. Now let me show you an example with loss. So here you can see, after from second hop we have packet loss, and this is my ISP gateway. That simply means that something is wrong between my gateway and the ISP side gateway. Okay, so I need to track what is the problem. Even here also you can see we have some packet loss. With help of traceroute you can determine at which particular hop you have the problem. Once you determine where you have the problem, then you can go for the solution. Correct? Okay. So before going further, what I want to show you here, that we have one good tool called MTR. You can install MTR into the system. You can use this URL. Once you run this application, once you trace route, then what will happen, it will show you that at which particular hop or at which particular gateway you have how much of packet loss. So here you can see it is showing the transit packet loss. So at ISP gateway 75, then next hop 60, 70, like that. So this much of packet losses we have at all the hop counts. You can use this tool, this very nice tool, to determine at which particular hop count we have the packet loss. Now let's see our topology. Inside our topology diagram, say a customer, a client, they log one ticket. They are telling, okay, my users, they are experiencing latency, or the applications that they are opening here, they are very slow. What you can do, now you can see how many touch points you have. So suppose I have touch points, say 1, say 2, say 3, 4, 5, like that. But when we are talking about the applications, generally we are checking it end to end. Or suppose if you determine, say I have problem on this PC from this side, say A, and I have problem here in this particular box B. So once I reach to this particular point, then I'll try to narrow down the problem. Then I'll ping here. Then I will find, okay, now I have problem in between, say A and B there is C. In between A and C, suppose this is my A. Now again what I will do, I will ping to this. Then I will check, okay, there is other entity, say E here. In between E I have the problem. Then I will check only the link between my PC and the RF or the AP. Okay, so what is the approach here, that you have to narrow down the problem. Okay, and you can narrow down the problem once you go a step by step, means once you do the step by step troubleshooting. So in this case, suppose first of all I am pinging to the AP. Say if I have any problem with the AP, then I will check, means if I ping and if I have loss, I will check the AP. Now how you can check the AP latency related to AP? So I have given one link here at the bottom. Just go here, you can get this Wi-Fi best practice troubleshooting performance, where you will get much more information about the packet loss at the level of AP or troubleshooting at the level of AP. Okay, then what you have to do, that then you can ping here to this PC. Say suppose if you ping to this particular PC, that means if you have any problem with the switch, you can identify it. So this approach is something that we are doing from, say, bottom up. So first of all we are checking the nearby device, and then we are checking the far end device. Even the other approach is, say, top down. Top, here is TOP, top, and then down. Top down approach means what? First you check the end device, and then the second end device. Likewise, you narrow down your ping or traces or troubleshooting. Okay, so here in this example we have this bottom up approach. In protocol suite we are telling this as a bottom up approach, something that we are troubleshooting from say physical layer, data link layer, and top. Okay, you got my point. So this is one type of this is one type of troubleshooting that first of all we are checking the cabling connection, the media type, the wire connection, the physical resources, the electricity, all these stuffs. Okay, then we are checking with respect to say layer 2, so how the layer 2 protocols are working, say in non-Cisco, say in non-Meraki world, something like STP or PPP or HLD, PPP or HLDC or HDLC, sorry, SDLC, whatever layer 2 protocols we have. Okay, we are checking that. Then we are going to ping test, that is layer 3, means with help of ICMP we are checking those things, so ICMP, trace route, etc. Then we are checking at the level of TCP layer, so whatever application related to TCP we are checking that, and then finally we are checking the applications. Okay, so it depends that how you are doing your troubleshooting. You are going from say bottom up or top down. Okay, next I will ping here. If I found any problem here, then I will troubleshoot between this path number 2. Then I will check the path number 3 between this PC, then AP, then one switch, then other switch, then this particular PC. So what you can do here, that suppose if you are troubleshooting the wireless device, you can simply ping to mymeraki.com, and in between suppose if you have problem here, then you can check the speed, duplex, and the cable type. Suppose if you find problem here, then again you can check speed, duplex, and cable type. Suppose if you have problem in this segment, you can check speed, duplex, and cable in this segment. So likewise, segment by segment you can check all those stuffs. Now what are the common cause for packet loss? So we have some common cause, something called say duplex mismatch, link congestion, firewall blocking certain traffic, and bad cabling and loose connection. So let us discuss all these things one by one. This is very common, like duplex mismatch. So suppose if one side you have say auto, use other side auto as well. If you are using say half duplex, other side also, actually this is full duplex. So one side we have full duplex, other side full duplex, or half duplex, that will be okay, but auto full duplex will not work. Say full duplex and half duplex will not means it will work, but you will get some packet loss. So use the recommended practice. Then suppose if you have fast talker and slow listener, at that time also you have a problem. So suppose this the capability of this link is say to hold 20 Mbps, and if you send 60 Mbps traffic, obviously 20 Mbps will drop down. So what is the solution for that? The solution is that you upgrade the bandwidth according to your requirement. The other solution is that you prioritize the traffic. You give some more priority to latency or jitter sensitive application than the other traffic. The third solution here is that you can categorize the traffic and you can allocate the bandwidth. Okay, so you can go to the traffic shaping rule, and from there you can limit the volume of traffic, particularly decreasing the volume of undesired traffic. So whatever traffic that is not that much in use, you can decrease the volume of that. Okay, then there are chances that everything is fine, but still you are seeing that some of the applications are slow. That means your firewall is blocking those. So be sure or make sure that you're allowing all those traffics through your firewall, through your security gateways, which you want to use inside your business. Okay. Then finally we have this bad cable or loose connection. So you have to check that cable is properly connected or not. Then you can see here that it is seated properly or not. Do you have any dust in that cable? The signaling is correct or not? Even you can do the cable test as well for this. Okay, so make sure that you are using all these parameters. Then you will come to know that which of the particular parameter, either duplex, speed, link, firewall, bad cabling or loose connection, hitting the problem, and this way you can solve this packet loss problem inside the Meraki network. In case of WAN link issue, how we can collect the logs or how we can proceed, we have one use case, one scenario here, that client has one fault tolerant WAN link, and they report that okay, this link is down, how we can proceed on this. So what we can do here, first of all, we need to identify the issue. Although they are telling that okay, one of the WAN link is down, we need to identify that is it a primary link or is it a secondary link. Okay, so how we can determine that? Obviously we need to understand client network topology and the public IP addresses. So why it is important to identify or understand that primary link is down or secondary link is down? The answer is, if you see the client infrastructure or environment, you will find that either they have type 2 branch. So what does it mean by type 2 branch? Type 2 branch means that they have two Meraki devices and they are HSRP or VRRP configured, and then one Meraki device is connected with one modem, other Meraki devices connected with other modem. Means the connection is something like one device is connected with one ISP, other device is connected with other ISP. Now the other type of type 1 branch they may have, that they may have single device and one device is connected with one modem, then one ISP, and the second device is connected with other modem, then the ISP. So in short, they have primary and secondary link, but most importantly here you have to understand that they have primary, secondary, but if you see the bandwidth subscribed, you'll find that one link is almost say 50-60% more capable than the other link. So suppose if one link is of say 100 MB, the other link may be of say 20 MB, because what customer want, that they subscribe one primary link and they want to run their application over primary link. Okay, so that's why they have this type of a structure. So all these data, all the critical application, or most of the traffic or load you will find over the primary link. Say in Meraki, obviously we have this auto load balancing method, but still if you see the load on the secondary link, you will find there is less load in the secondary link. In this case, suppose if primary link go down, then we need to identify that although the services are running over the secondary link, but still what is the outage? Do all the critical applications they are running properly over secondary link? So that's why it's very important to first of all identify, is it a primary link or secondary link, which link is down. Okay, so suppose my primary link is down in our case, then how we can proceed? So client, they have reported that their primary link is down, but still we need to collect the logs, because we can't trust on anything rather than what log says. So what you have to do to collect the log, first of all you have to go inside the Meraki dashboard, you have to use your username and password, and then we have to collect the log. Now while collecting the log, you can see here that we have to go inside the network wide. So let me show you what I tried to explain here. Once you log to that particular branch, maybe branch is ABC, then you will find options there. So we have option related to network wide, we have options related to security appliances, we have option related to org. Now what log you will collect? We have to collect two log. First log is, we have to go inside network wide, monitor event. Once you go inside that, then you have to filter with primary uplink status change. Once you filter, click enter in the search box, then you will get this type of output. Then you'll come to know, okay, primary uplink status change 0 or 1. Okay, so this is the way that you figure out that, okay, it is 0 means false, 1 means true. It has been flapped or not, because these things you have to attach in the case note. Okay, once you identify that, then the second step is to take the log related to VPN. So for that, you can go inside this security appliance, and then you have to select VPN status. Here you can see I have taken one log where you can see that the VPN was down in this particular duration. Now suppose this VPN is down, that means entire branch is out of network. Generally what happens in the branch, that they have VPN A and B, means because they have two connection. Suppose if they have two data center and then they have one branch, they may have VPN A and VPN B. But suppose if both the VPNs are down, you will get some red zone here in the down in this particular output. That means we have complete outage. Means suppose in that case means that both the links are down. Okay, that will be very critical, very severe. We quickly have to raise P1 case for that. But anyways, here we know that one of the link down. With these two logs you will get the information about the link down. Once you identify the issue, then the next step is to take the action, obviously. So what you can do here, that for the safety purpose, you will check. What you will check? You will check the status of the modem. So either it is a type 1 or type 2 branch. You will check the physical status of these modems. You will check the physical status of this particular interface. And suppose in case of two devices, you have to check the physical status of devices as well. So in case of type 1 branch, what you have to do, suppose if your device is down, both the link will be down, obviously. So in that case, what you have to do, you have to check the physical status of this interface, the physical status of this modem, plus the physical status of this modem. Once you are okay, once you are fine that okay, all the physical interfaces or physical status of a device are up and okay, then you have to raise a case with the ISP. So then you need to take a log, and then you have to send to the concerned ISP, and then you can tell them, okay, I'm gathering the logs. It seems that one of the link is down. You have to check from your side, and then you have to follow up with the ISP. So these are the process or procedure that you have to follow. I hope you understand this type 1 and type 2 is really important. Plus it is very important to identify primary is down or secondary is down, and we have to correlate all these stuffs, all these things with the topology that is provided by the client.